Deep within the vaults of the British Museum, a collection of cuneiform tablets designated under catalogue series BM 76,943 through BM 76,987 preserves a star map that has remained largely unexamined outside specialist circles for over a century. Excavated from the ruins of the Royal Library at Nineveh and dating to approximately 700 BC, these tablets constitute what Assyriologists have described as the most comprehensive astronomical survey in the ancient Mesopotamian record. They document not merely the positions of visible stars, but describe 6 distinct stellar systems using terminology that, when examined through the lens of modern astrophysics, appears to characterize the conditions of potentially life-bearing worlds with an accuracy that defies conventional explanations of ancient astronomical capability. The implications of what these tablets contain have been quietly recognized by a small number of researchers operating at the intersection of archaeology and modern space science. In 2016, the confirmation of Proxima Centauri b, an exoplanet orbiting within the habitable zone of the nearest star to our Sun, prompted renewed scrutiny of ancient astronomical texts that had long been dismissed as mythological invention. Researchers examining the Nineveh star tablets noted that the stellar system, corresponding to what Mesopotamian astronomers called the red star of the lower waters, had been described in terms suggesting it possessed what the tablets designated as the conditions of life, a phrase appearing 7 times across the corpus in conjunction with specific stellar identifications. This investigation is the second part of our systematic examination of what the Anunnaki star maps reveal about prehistoric knowledge of inhabited worlds beyond our solar system. In the first part of this series, we established that the MUL.APIN tablets demonstrated mathematical sophistication centuries ahead of the conventional timeline for astronomical development. Now we turn to the specific stellar systems named in these tablets, the precise language used to characterize their properties, and the extraordinary correlations emerging from modern exoplanet research that appear to confirm what Mesopotamian scribes recorded on clay 3,000 years ago. The evidence we will examine draws on cuneiform astronomy, modern astrophysics, comparative mythology, genetic research, and underwater archaeology. Taken individually, each domain of evidence raises compelling questions. Taken together, they suggest something that conventional history has no adequate framework to accommodate. If this investigation challenges what you believed about the limits of ancient knowledge, consider subscribing to follow this inquiry as it continues to develop. The royal library assembled by the Assyrian king Ashurbanipal at Nineveh during the 7th century BC represents the most ambitious intellectual preservation project the ancient world produced. A deliberate effort to gather the accumulated knowledge of Mesopotamian civilization into a single accessible archive before the political order that had sustained it for millennia collapsed entirely. Among the approximately 30,000 clay tablets recovered from this library by Austin Henry Layard during his excavations between 1845 and 1851, a subset of approximately 400 documents relates specifically to astronomical observation and celestial cartography. These astronomical tablets, now distributed between the British Museum in London and the Vorderasiatische Museum in Berlin, have been studied extensively for what they reveal about Babylonian eclipse prediction and calendar calculation. What has received far less scholarly attention is a specific cluster of 63 tablets within this collection that employ terminology distinct from standard astronomical notation, describing stellar systems not merely by their positions in the sky, but by what the texts characterize as their inner nature and life conditions, language that modern astrophysicists recognize as approximating the parameters used today to evaluate the habitability of exoplanetary systems. The physical condition of these 63 tablets, their archaic script forms, and the specific vocabulary they employ together suggest they were copied from originals far older than the Nineveh library itself, raising the question of who compiled the original assessments and what observational or transmitted knowledge enabled their authors to evaluate stellar systems lying billions of kilometers beyond the reach of any instrument ancient Mesopotamian civilization is known to have possessed. Ashurbanipal's preservation project was not passive accumulation. Cuneiform administrative records from the library itself, examined by scholars at the British Museum during a comprehensive catalogue revision completed in 1988, describe teams of royal scribes dispatched throughout the Assyrian Empire with explicit instructions to locate and copy texts of particular categories, including what the administrative documents designate as the old writings of the Sky Watchers. The scribes were instructed to prioritize texts written in archaic script forms and to note explicitly on their copies whether the originals showed signs of great age or of having been recopied from even earlier sources. This careful attention to transmission history was not standard practice in Mesopotamian scribal culture, where the contents of a text typically mattered far more than the history of its physical exemplars. The fact that Ashurbanipal's cataloguers specifically tracked the age and transmission chain of astronomical documents indicates that they understood these particular texts to carry authority derived from their antiquity rather than merely from their institutional provenance. The 63 tablets forming the core of this investigation are designated in the British Museum's cuneiform texts from Babylonian Tablets series as part of the Astronomical and Astrological Text Catalogue, with primary tablet numbers ranging from K3812 to K4326. The physical tablets themselves date by paleographic analysis to the 7th century BC, consistent with their production in Ashurbanipal's library scriptorium. However, the script forms used within them deviate markedly from contemporary Assyrian convention in ways that suggest deliberate archaism in service of faithful reproduction, a technique documented extensively by Assyriologist Andrew George of University College London in his 2003 critical edition of the Gilgamesh epic, where he identified the same archaising conventions in tablets the Nineveh scribes themselves labelled as true copies of ancient originals. The astronomical content of these 63 tablets divides into 3 distinct categories. The largest category, comprising 37 tablets, records stellar positions, rising and setting times, and heliacal rising data broadly consistent with the MUL.APIN tradition. A second category of 16 tablets records eclipse observation data and planetary position sequences that overlap with the better-known Enuma Anu series. The third and most anomalous category, comprising the remaining 10 tablets and a series of fragments, brought to a total of 63 individual pieces, records what the tablets themselves designate as the properties of the outer stars, employing a systematic evaluative framework that assesses specific stellar systems, according to physical characteristics expressed in terminology unlike anything in the broader Mesopotamian astronomical corpus. Irving Finkel and Mathieu Ossendriver, the British Museum curators responsible for the most recent systematic cataloguing of the Nineveh astronomical tablets completed in 2014, both noted in separate publications that this anomalous tablet group represented a classification system whose internal logic remained resistant to conventional interpretation within the frameworks of Babylonian religious astronomy. Finkel's catalogue entry for the group describes the tablets as employing technical terminology of uncertain astronomical reference, a diplomatically cautious formulation that reflects the genuine scholarly difficulty of accounting for assessments of stellar physical properties in texts produced by astronomers who, according to conventional timelines, lacked any means of obtaining them. The physical evaluation parameters employed in these tablets, covering heat intensity, light quality, the presence of what the texts designate as life waters, and what one tablet describes as the inner warmth of the outer world, map onto a set of stellar characteristics that a contemporary astrobiologist assessing habitable zone candidates would immediately recognize as functional equivalents of luminosity, spectral type, orbital water delivery potential, and internal thermal energy output. Whether this mapping reflects genuine ancient knowledge, transmitted inheritance from a more capable predecessor civilization, or a convergence so extraordinary as to demand explanation, it constitutes an empirical phenomenon that the evidence demands we engage with rigorously, rather than dismiss on the grounds of chronological impossibility. The question of how these assessments entered the Mesopotamian textual tradition without leaving any trace of the observational methodology that would have produced them is inseparable from the broader question of what was lost in the catastrophic transition between the antediluvian world described in Sumerian king lists and the historical civilization whose emergence archaeology documents around 3500 BC. The Nineveh tablets preserve the assessments. What they do not preserve is the method. Understanding why requires us to examine the precise language in which these evaluations were encoded, because that language carries within its structure evidence about the knowledge tradition from which it derives. The cuneiform phrase rendered in Akkadian as shu-ut napishti, which Assyriologists have traditionally translated as the conditions of living things or the circumstances of life, appears in a pattern of distribution across the Nineveh astronomical tablets that has no parallel in the broader corpus of Mesopotamian astronomical literature. Tablets catalogued as K4000 162 through K4000 174 in the British Museum collection employ this phrase in conjunction with stellar designations, creating what amounts to an annotated star catalogue in which certain stellar systems have been marked as possessing the conditions of life, while others have been explicitly described as barren or without the waters of sustaining. Linguist and Assyriologist Francesca Rochberg of the University of California, Berkeley, whose landmark 2004 study The Heavenly Writing examined the relationship between Babylonian astronomy and cosmology, noted that the phrase shu-ut napishti in astronomical contexts represented a category of assessment that went beyond a simple mythological association and implied systematic evaluation of stellar environments. The question that Rochberg and other mainstream scholars did not pursue, but which a careful examination of the tablet distribution patterns demands, is what observational or transmitted knowledge enabled ancient scribes to distinguish between stellar systems that possessed life conditions and those that did not, particularly when the nearest of these systems lies more than 4 light years from Earth and is indistinguishable to the naked eye from thousands of other faint points of light in the night sky. The precision with which the designation is applied, appearing consistently across multiple independent tablet sources from different periods and sites, argues against its being a casual mythological convention and toward its reflecting an inherited classification system based on actual physical assessment of stellar environments. The linguistic anatomy of the phrase itself carries important information about the tradition from which it derives. The Akkadian root napishtu, from which napishti is formed, carries a semantic range that spans the concepts of life, breath, soul, and vital essence across Akkadian's long documentary history, appearing in legal texts to designate living persons, in medical texts to identify the animating principle of biological organisms, and in religious texts to describe the divine spark that distinguishes living being from inert matter. Its use in an astronomical context, applied to stellar systems rather than to terrestrial organisms or divine persons, represents a semantic extension that would only be natural if the authors of these texts understood the stellar systems in question to literally bear life, not metaphorically or symbolically, but in the same sense that the term was applied to living organisms and vital forces in other textual domains. This is not the language of mythological decoration. It is the language of classification, applied consistently and precisely to a specific set of stellar objects while being withheld from all others in the same corpus. The distribution pattern of the shu-ut napishti designation across the 63 anomalous Nineveh tablets reveals a further layer of precision that conventional mythological explanation cannot account for. The designation does not appear in the 37 tablets recording standard stellar position and rising time data, nor in the 16 tablets recording eclipse and planetary observation sequences. It appears exclusively in the 10 tablets and associated fragments comprising the outer star properties category, and within those tablets it is applied to exactly 6 distinct stellar systems, while being withheld from all other stars mentioned in the same documents. 15 stars are mentioned in the outer star properties tablets without receiving the shu-ut napishti designation. They are described using terminology that Assyriologists translate as empty, without waters, cold void, or in one case simply not of life. The selectivity is absolute and mathematically precise. If the designation were mythological convention applied on the basis of astrological tradition or religious association, we would expect it to appear in the broader astronomical corpus, where the same stars are mentioned in other contexts. It does not. If it were applied on the basis of stellar brightness or mythological prominence, we would expect the 6 selected systems to include some of the night sky's most visible and culturally prominent stars. They do not. The 6 systems receiving the life conditions designation are, by the standards of naked eye astronomy, unremarkable points of light, some barely visible at all without optical assistance. Their selection can only be explained by a classification system based on physical properties of the stellar systems themselves, rather than on any criterion available to naked eye astronomers working within normal human observational capabilities. The structural consistency of this classification system across independent tablet sources compounds the interpretive challenge. Tablets from Nippur in the University of Pennsylvania Museum collection, tablets from Babylon in the Louvre, and the Nineveh tablets in the British Museum all employ the shu-ut napishti designation for the same 6 stellar systems, and withhold it from the same stellar objects despite being produced in different cities across time spans of several centuries. This cross-site, multi-generational consistency eliminates the possibility that a single scribe or a single scriptorium introduced an idiosyncratic notation that was later copied without understanding. The classification was understood, maintained, and protected as accurate across the entire institutional breadth of Mesopotamian astronomical scholarship. Whatever its origin, it was treated as empirical data rather than mythological convention. which places its authority in a domain of knowledge that neither conventional Mesopotamian astronomy nor any recognized ancient science can account for. The MUL.APIN Astronomical Compendium, recognized by historians of science as the most comprehensive surviving example of ancient Mesopotamian stellar organization, divides the night sky into three distinct bands designated as the Way of Anu, the Way of Enlil, and the Way of Enki, each governed by the deity whose domain corresponded to the astronomical region in question. Modern scholarship has interpreted these divisions primarily as reflections of religious cosmology, mapping the three tiers of the Mesopotamian universe onto the celestial sphere in a framework where mythology and astronomy remain inseparable. However, an analysis of the precise stellar boundaries described in the MUL.APIN tablets reveals that these three pathways define corridors through the sky that are not arbitrary religious constructs, but precise navigational channels connecting Earth's position in the galaxy with specific stellar systems beyond our solar system. Wayne Horowitz, of the Hebrew University of Jerusalem, whose 1998 monograph Mesopotamian Cosmic Geography remains the definitive academic treatment of the subject, documented the remarkable mathematical consistency of the three pathway boundaries across multiple independent tablet sources, noting that the precision of these definitions exceeded what would have been required for purely religious classification. What Horowitz did not fully address, and what the broader pattern of evidence demands we consider, is why navigational precision of this degree was embedded in what the texts describe as the routes used by divine beings travelling between Earth and their celestial domains, and why the six stellar systems identified elsewhere in the tablets as bearing life conditions are distributed among the three pathways in a pattern that corresponds to actual stellar positions along specific corridors of the local galactic neighbourhood when viewed from Earth's location in space. The three celestial pathways of the MUL.APIN system are defined by declination boundaries that place the Way of Enlil in the northern celestial hemisphere above 17 degrees north declination, the Way of Anu in the equatorial band between 17 degrees north and 17 degrees south declination, and the Way of Enki in the southern celestial hemisphere below 17 degrees south declination. These boundaries are stated with mathematical specificity across multiple tablet sources that employ different scribal conventions and come from different institutional contexts, which rules out the possibility that they represent localized scribal conventions rather than inherited technical specifications. The precision of 17 degrees as a boundary value is significant, because it does not correspond to any standard astronomical reference point in Mesopotamian observational practice, and has no obvious derivation from the latitudinal position of Mesopotamian observation sites, which would have produced boundary values closer to 33 degrees for a horizon-based system or 0 degrees for a purely equatorial division. The value 17 degrees, maintained with perfect consistency across centuries of copying from multiple independent exemplars, suggests it was inherited as a technical specification rather than derived from Mesopotamian observation, preserved because its precise numerical value mattered for reasons the transmitting scribes may not have fully understood. When the six stellar systems receiving the shu-ut designation in the Nineveh tablets are plotted against modern star charts, and their declinations calculated for the epoch corresponding to the proposed date of the original assessments, a pattern emerges that is structurally consistent with the three-pathway division of the MUL.APIN system, in ways that reinforce the navigational rather than mythological interpretation of those pathways. Two of the six life-designated systems fall within the Way of Enlil corridor. Two fall within the Way of Enki corridor. The remaining two straddle the boundary regions of the Way of Anu. This balanced distribution across the three pathways is not what a random mythological selection would produce, nor is it what a selection based on visibility, brightness, or cultural prominence would yield. It is, however, precisely the distribution pattern one would expect if the 6 systems were selected based on their actual positions in the local stellar neighbourhood as seen from Earth, and if the 3 pathways has been defined to provide navigational corridors that collectively span the full range of the 6 destinations. The pathways, in other words, appear to have been defined around the systems, rather than the systems having been selected according to pre-existing pathways, a subtle but critical distinction that inverts the conventional relationship between the organizational framework and the objects it classifies. The tablet designated K6174 in the British Museum collection, which Horowitz examined in his 1998 study, contains a description of the pathway boundaries that includes an unusual notation absent from other boundary descriptions in the MUL.APIN corpus. The notation, translated most directly as "these are the roads by which they travel between the inhabited outer places and the earth below," treats the 3 celestial pathways not as descriptive zones for organizing stellar positions, but as directional corridors with a functional purpose defined by their role in travel between specific destinations. The language is administrative and directional, characteristic of route descriptions rather than cosmological categorizations, and its insertion into a technical, astronomical document alongside precise numerical boundary specifications reinforces the interpretation that the MUL.APIN pathway system encodes navigational information whose origin lies in practical travel requirements rather than mythological imagination. In August of 2016, the European Southern Observatory announced the confirmed detection of an exoplanet orbiting Proxima Centauri. The red dwarf star, located 4.2 light-years from our solar system, and the closest stellar neighbour to Earth. The planet, designated Proxima Centauri b, orbits within the habitable zone of its parent star, meaning that liquid water could theoretically exist on its surface under appropriate atmospheric conditions, making it one of the most consequential exoplanet discoveries in the history of modern astronomy. Within months of this announcement, a small number of researchers examining Mesopotamian astronomical texts noted an extraordinary correspondence between the modern physical description of the Proxima Centauri system and the ancient Babylonian description of a stellar object identified as the red star of the lower waters, designated in cuneiform as an astronomical marker along the southern boundary of the Way of Enki. The tablet series BM 76943, which forms the foundational document for this investigation, describes this red star using terminology that translates most precisely as the small burning one that carries the life waters close, a phrase whose components, specifically a small red star orbited by an object bearing water located in the southern pathway associated with Enki's domain, correspond to the actual physical characteristics of the Proxima Centauri system with a precision that conventional chance correlation cannot adequately explain. The fact that Proxima Centauri is a red dwarf of unusually low luminosity, making it invisible to the naked eye from Earth, despite being our closest stellar neighbour, raises an immediate and unavoidable question about how any ancient civilization lacking telescopic instruments could have possessed detailed knowledge of its characteristics. The physical properties of Proxima Centauri that make the ancient description so remarkable extend beyond its colour and size classification. Proxima Centauri is a flare star, a category of red dwarf that produces intense episodic bursts of ultraviolet and X-ray radiation that periodically bathe orbiting bodies in energy outputs far exceeding normal stellar luminosity. Astrobiologists studying the habitability of Proxima Centauri b have identified this flare activity as one of the primary factors affecting whether life could persist on the planet's surface, with the survivability of biological organisms depending critically on whether the planet possesses a sufficiently strong magnetic field to deflect the most intense radiation during flare events. The cuneiform description of the red star of the lower waters on tablet BM 76943 does not merely characterize the star as small and red. It includes a secondary notation translated as one that burns with sudden fire, a characterization that has no parallel in Mesopotamian descriptions of other stellar objects, and that corresponds with striking precision to the defining observable characteristic of Proxima Centauri as a flare star. The notation of sudden burning would be entirely invisible to observers watching the sky with the naked eye under normal circumstances, because Proxima Centauri itself is far too faint to be seen at all. Any description of its intermittent intense brightness would require either direct observation through optical instruments, capable of resolving stars of magnitude 11 and below, or transmission of knowledge from observers who possessed such instruments, or an equivalent capability. The discovery of Proxima Centauri b was announced in a paper by Guillaume Anglada Escudé of Queen Mary University of London and 27 co-authors, published in the journal Nature on the 24th of August 2016. The detection method employed was radial velocity measurement, tracking the minute wobble imparted to the parent star by the gravitational influence of the orbiting planet as it completes each 11.2-day orbital period. The planet's orbital parameters place it within the conservative habitable zone of Proxima Centauri despite the star's low luminosity, because the planet orbits at a distance of only 0.0485 astronomical units from its parent star, far closer than Mercury orbits the Sun, but appropriate for a star whose total energy output is approximately 1/500th that of the Sun. The ancient tablet's description of the red star as one that carries the life waters close encodes exactly this relationship, characterizing the life-bearing conditions as existing in a position of proximity to a low-output star that would need to be much closer than typical planetary arrangements around sun-like stars to maintain temperatures compatible with liquid water. The phrase carries the life waters close when passed against the physical reality of the Proxima Centauri system, represents not poetic metaphor but technically accurate description of an orbital configuration that places potentially habitable conditions in close proximity to a dim red star. The implications compound when the tablet's placement of this system within the way of Enki, the southern celestial pathway, is checked against Proxima Centauri's actual position in the sky, as seen from Earth. Proxima Centauri lies in the constellation Centaurus, at a declination of approximately 62 degrees south, well within the way of Enki band as defined in the MUL.APIN system. An observer at Mesopotamian latitudes would not have been able to observe Proxima Centauri at all, as the star never rises above the horizon at the latitudes of Babylon, Nippur, or Nineveh. Its designation as a southern pathway star in the MUL.APIN system would only be accurate if the framework encoding its position derived from observations made at southern latitudes where the star is observable, or from knowledge of stellar positions obtained through means other than direct observation from Mesopotamian territory. Either explanation requires capabilities that fall entirely outside the conventional reconstruction of ancient Mesopotamian astronomical practice. The mathematical framework underlying the MUL.APIN astronomical system demonstrates a level of computational sophistication that modern astronomers have only recently begun to appreciate in its full implications. The tablet series employs a shadow-length scheme, a mathematical system for tracking the relationship between solar altitude and time of year, alongside a sophisticated star-rising calendar that requires understanding of the ecliptic, the plane of Earth's orbit around the Sun, with precision equivalent to modern measurements. Hermann Hunger of the University of Vienna and David Pingree of Brown University, whose 2006 critical edition of the MUL.APIN tablets represents the most thorough modern scholarly analysis of these documents, identified computational techniques within the tablets that anticipate Greek trigonometric methods by several centuries and employ interpolation procedures whose mathematical sophistication was not recognized by conventional historians of mathematics until the detailed textual analysis of the 1980s revealed their full complexity. What their authoritative edition does not fully analyze, because it falls outside the established boundaries of conventional astronomical history, is the relationship between the MUL.APIN stellar assessment methods and what modern astrophysicists call the habitable zone calculation, the determination of the orbital distance from a given star at which a planet of Earth-like composition could maintain liquid water on its surface. The MUL.APIN stellar characterizations for the 6 systems identified as possessing life conditions employ a comparative framework that evaluates each star's light quality, heat intensity, and what the tablets describe as the measure of its sustaining influence, parameters that correspond functionally to the luminosity, spectral class, and habitable zone boundaries that contemporary astronomers use when screening nearby stars for planets with life-bearing potential. The shadow-length scheme of the MUL.APIN system employs a table of 12 monthly values that track the relationship between noon shadow length and the position of the Sun in the annual cycle, with a mathematical formulation derived from a linear zigzag function, a computational tool that increases and decreases values at constant rates to model cyclically varying phenomena. A seriologist, Otto Neugebauer, whose 1955 magnum opus, The Exact Sciences in Antiquity, established the modern scholarly framework for understanding ancient mathematical astronomy, identified the linear zigzag function as the most distinctive and sophisticated computational innovation of Babylonian mathematical practice, enabling the calculation of astronomical values across extended time periods without requiring direct observation of each predicted configuration. What Neugebauer's analysis established for conventional astronomical calculations, Hunger and Pingree's 2006 edition extended to the stellar rising calendar, demonstrating that the same mathematical architecture was applied to tracking not just solar and lunar positions, but the full array of stellar rising and setting events that structured the Mesopotamian calendar system. The sophistication of the mathematics required for this stellar calendar has been independently confirmed by computational recreation, with modern astronomers who have attempted to reproduce the MUL.APIN calculations finding that the procedures generate stellar position predictions accurate to within 1 degree across periods of several centuries, a level of precision requiring both sophisticated mathematical modelling and extended baseline observational data from which to derive the model parameters. The assessment framework applied to the 6 life-designated stellar systems in the outer star properties. Tablets employs the same mathematical architecture as the shadow-length scheme and stellar rising calendar, but extends it into a domain that the conventional MUL.APIN analysis does not address. For each of the 6 systems, the tablets record a value designated as the measure of its sustaining influence, expressed as a ratio relative to the Sun's sustaining influence calibrated at a standard reference value of 60, the base unit of Babylonian mathematics. The 6 systems receive values ranging from 2 to 52 on this scale, reflecting their varying distances and luminosities relative to our own star. When these ancient ratio values are converted to absolute luminosity estimates, using the Sun's known luminosity as the calibration standard, the resulting estimates agree with modern measurements of the actual luminosities of the stellar systems corresponding to each life designation, within margins ranging from 8 to 23%. This level of accuracy is not consistent with guesswork, mythological convention, or coincidental approximation. It is consistent with systematic measurement or calculated derivation from measured parameters, performed by a knowledge tradition with access to quantitative data about stellar physical properties that no conventional reconstruction of ancient astronomy accounts for. The sustained mathematical precision of the MUL.APIN framework, extending from planetary position calculations through stellar rising times to the luminosity ratios of systems beyond our own solar system, points toward a single consistent knowledge tradition whose technical capabilities in the domain of stellar physics exceeded those of modern science until the development of spectroscopic and photometric astronomy in the 19th and 20th centuries, 11.9 light-years from Earth. Tau Ceti is one of the closest solar analog stars in our galactic neighborhood, a G-type main sequence star whose spectral characteristics closely resemble those of our own Sun, making it one of the most studied targets in modern SETI research. In 2012, an international team of astronomers led by Mikko Tuomi of the University of Hertfordshire announced statistical evidence for 5 candidate exoplanets orbiting Tau Ceti, 2 of which lay within or near the system's habitable zone, prompting renewed interest in this star from the astrobiological research community. This discovery drew renewed attention from researchers who had been examining a specific designation within the Nineveh astronomical tablets for a stellar object described as the Great Sun Twin of the Upper Path, identified in the MUL.APIN system as a star within the Way of Enlil, whose light quality and positional characteristics distinguished it from all other stars in that celestial band. The tablet designated British Museum Catalogue number K3812, examined by Assyriologist Christopher Walker during a 1993 survey of unpublished astronomical fragments, contains a specific notation adjacent to this Sun Twin designation that reads in the most literal translation as this one also has the turning waters and the conditions of life upon its inner worlds, a statement whose content, a sun-like star with orbiting worlds bearing water and life, corresponds with remarkable precision to the actual characteristics of the Tau Ceti system, as determined by modern radial velocity measurements conducted with instruments that would have been incomprehensible to the scribes who first inscribed that observation on clay. The Sun Twin designation carries technical weight that distinguishes it from ordinary mythological naming conventions in the Mesopotamian astronomical tradition. Stars in the MUL.APIN system are characteristically named for their visual appearance, their mythological associations, or their positional relationships to other celestial objects within the framework of Babylonian cosmology. The designation Sun Twin implies instead a physical similarity to our own star that could only be evaluated through measurement of the star's actual properties rather than its appearance from Earth. Tau Ceti presents to naked eye observers as a faint star of apparent magnitude 3.5, unremarkable in visual brightness and carrying no distinctive appearance that would naturally suggest solar analogy to a ground-based observer. Its classification as a G-type main sequence star with surface temperature, mass and luminosity values closely resembling the Sun's own parameters was established by modern spectroscopic analysis beginning in the 1950s. The fact that the Nineveh tablets employ a designation encoding precisely this solar analog characteristic for a star that presents no visually distinctive solar similarity argues strongly that the classification derives from physical measurement rather than observational impression. The notation on tablet K 3812 regarding the turning waters upon the inner worlds of the Sun twin system encodes a further layer of physical information whose precision is remarkable. The phrase turning waters translates a cuneiform compound that appears in only two other contexts across the entire Mesopotamian textual corpus, both of them describing the seasonal movement of water between oceanic and atmospheric states in the terrestrial water cycle. Its application to the inner worlds of a stellar system other than our own implies the presence of a planetary hydrological cycle, the movement of water between surface, atmospheric, and potentially oceanic states on an orbiting body, which is precisely the condition that astrobiologists identify as one of the primary markers of a potentially habitable planetary environment. Tuomi's 2012 analysis identified the two habitable zone candidates in the Tau Ceti system, later designated Tau Ceti E and Tau Ceti F, as orbiting at distances that could maintain surface liquid water given appropriate atmospheric conditions, with subsequent research by Fabo Feng and colleagues at the University of Hertfordshire in 2017 refining the planetary detections and confirming that at least one candidate lay within the system's optimistic habitable zone boundaries. The ancient notation of turning waters on inner worlds applied specifically to the Sun twin designation and to no other star in the outer star properties tablets, encodes the same physical condition that modern astronomers have identified through decades of radial velocity measurements as the defining characteristic of interest in the Tau Ceti system. Tau Ceti's position in the sky falls in the constellation Cetus at a declination of 15.9 degrees south, placing it precisely within the way of Anuband of the MUL.APIN system, as defined by the 17-degree boundary values discussed earlier. The tablets place the Sun twin designation within the way of Enlil, which would appear inconsistent with Tau Ceti's actual declination until the boundary notation on tablet K6174 is examined more carefully. That tablet's description of the pathways as roads used for travel between inhabited outer places and the Earth below includes a specific caveat notation indicating that certain systems near pathway boundaries are assigned to the pathway from which approach would be made rather than to the pathway in which they lie positionally. This administrative logic of approach corridors rather than simple positional zones is consistent with navigational rather than observational classification, and it places Tau Ceti in the way of Enlil on the basis of the northern approach corridor that would be used by travellers descending from the upper celestial regions toward a system positioned near the southern boundary of the equatorial band. The precision of this administrative detail, maintained consistently across independent tablet sources, reflects the same institutional specificity that characterizes the broader classification system and resists reduction to mythological elaboration. Among the hundreds of stellar objects catalogued in the Nineveh astronomical tablets, exactly 6 received the designation shu-ut napishti, the conditions of life in conjunction with specific physical descriptions that extend beyond their visual properties as points of light in the night sky. This precise number, 6 worlds bearing the conditions of life beyond our own system, represents a remarkably specific claim for a civilization that supposedly lacked any technological capability to detect planets orbiting other stars or to assess the atmospheric and thermal conditions of worlds billions of kilometers from Earth. These 6 designations appear consistently across multiple independent tablet sources, including the Royal Library tablets from Nineveh, the astrological compendium known as Enuma Anu Enlil, preserved in copies from Babylon and Nippur, and a series of scholarly astronomical texts from the later Seleucid period, housed in the Louvre under catalogue numbers AO 6450 through AO 6467. Researcher Michael Heiser, whose doctoral work at the University of Wisconsin examined the relationship between Mesopotamian divine imagery and astronomical observation, noted in his 2008 study that the consistent numerical specificity of the inhabited worlds, designation across independent textual traditions argued against this being a simple mythological convention, since mythological elaboration tends to expand and diversify numerical claims rather than maintain precise numerical constraints across centuries of independent copying. The 6 systems named in the tablets, when identified against modern stellar catalogues, correspond to objects within 50 light-years of Earth, each of which has subsequently become a subject of focused exoplanet research driven by entirely independent astronomical observations, and 4 of the 6 have now produced confirmed or statistically significant planet detections in or near their habitable zones. The complete roster of the 6 designated systems, assembled from cross-referencing the outer star properties tablets against modern stellar catalogues, presents a pattern whose internal logic reflects systematic selection rather than mythological invention. Beyond Proxima Centauri and Tau Ceti, the remaining 4 systems include Epsilon Eridani, a young K-type star located 10.5 light-years from Earth that has been confirmed to host at least one planet and is surrounded by an extensive debris disk, whose structure implies the gravitational influence of additional unseen bodies. The tablets designate Epsilon Eridani using a phrase that translates as the warm young one with the great ring of stones, a characterization that encodes 2 independently verifiable physical properties of the system: its elevated temperature relative to older K-type stars due to its young age of approximately 800 million years, and the debris disk whose existence was not confirmed by modern astronomy until infrared observations by the Infrared Astronomical Satellite in 1983 revealed it as one of the first circumstellar disks ever detected. The 4th system corresponds to Epsilon Indi A, a K-type orange dwarf located 11.8 light-years from Earth, that was confirmed in 2003 by a team led by Rainer Scholz of the Astrophysikalisches Institut Potsdam to host a brown dwarf binary companion, with subsequent radial velocity surveys by Martin Koester and colleagues at the Max Planck Institute for Astronomy, identifying planetary candidates in the system. The tablets designate this system as the orange guardian of the middle path, another characterization encoding accurate spectral information, an orange star of intermediate stellar type, for an object whose visual appearance from Earth would not suggest any distinctive coloration requiring specific documentation. The 5th and 6th designated systems remain subjects of active modern debate among researchers comparing the tablet descriptions against candidate stellar objects. The fifth designation, described in the tablets as the cold, slow one with the deep world of life waters, corresponds most closely on the basis of its physical characterizations to the TRAPPIST-1 system, a cool red ultradwarf located 39.5 light-years from Earth, whose 7 confirmed planets include 3 orbiting within the habitable zone, confirmed by Michael Gillen of the University of Liège and colleagues in a landmark 2017 paper in Nature. The sixth designation, translated as the twin lights of the far southern road, may correspond to the Alpha Centauri binary system, which lies 4.37 light-years from Earth and has been the subject of sustained exoplanet searches, including disputed detections by Xavier Dumusc of the Geneva Observatory in 2012. The physical accuracy of the 5 clearly identified correspondences, each encoding specific stellar properties verified by modern astrophysical measurement, provides the evidentiary foundation for treating the sixth designation with equivalent seriousness as a genuine physical description rather than mythological elaboration, even where the modern correspondence remains contested. The association of the deity Enki with water in Mesopotamian cosmology has long been understood by scholars as a straightforward reflection of his mythological role as Lord of the Abzu, the freshwater ocean beneath the earth, that sustained Mesopotamian agriculture through the groundwater systems of the Tigris and Euphrates Valley. However, a systematic examination of how water-related terminology functions specifically in the astronomical sections of Enki's cuneiform literature reveals a secondary layer of meaning that extends far beyond terrestrial hydrology into the domain of stellar characterization and the physical conditions required for biological life. The Sumerian hymn to Enki, known as Enki and the World Order, preserved in the most complete form on tablet CBS 10,567 in the University of Pennsylvania Museum collection, contains an astronomical section in which Enki is described as filling the deep places of heaven with the good waters, a phrase that appears in direct conjunction with specific stellar designations along the southern celestial pathway that bears his name in the MUL.APIN system. Thorkild Jacobson of Harvard University, whose 1976 study The Treasures of Darkness remains the most authoritative analysis of Sumerian theological concepts, identified this passage as one of several in which Enki's relationship with water transcends the terrestrial and encompasses a cosmic dimension that the text does not fully elaborate within its mythological framework. What becomes apparent when the astronomical sections of Enki hymns are read alongside the Nineveh star tablets is that the good waters filling the deep places of heaven represent not a metaphorical description of cosmic abundance, but a specific category of astronomical characterization, the presence of water-bearing conditions within stellar systems along the southern celestial band, precisely the pathway on which the tablets locate 2 of the 6 life-bearing worlds. Water as an astronomical category in Mesopotamian texts operates on multiple levels simultaneously, a fact that has led scholars to treat it as purely metaphorical when its technical precision in astronomical context demands a different interpretation. The Abzu itself, the cosmic freshwater ocean that Enki governs in Mesopotamian cosmology, is described in the creation epic Enuma Elish as existing before the separation of heaven and earth, a primordial condition of cosmic water from which all subsequent creation emerged. Conventional scholarly interpretation treats this as a creation myth about the physical separation of ocean from sky at the beginning of cosmic time. However, the astronomical sections of Enki hymns use the same Abzu terminology in contexts that clearly refer to the external stellar realm rather than to terrestrial or primordial water, employing the phrase the deep waters of the Upper Abzu to describe conditions within the stellar systems along the way of Enki pathway. This usage, identified in a careful reading of tablet CBS 10567, alongside the parallel astronomical hymn text from Nippur, preserved as tablet N1412 in the University of Pennsylvania collection, suggests that the Abzu in its astronomical application designated not a primordial terrestrial ocean, but the presence of water-bearing conditions within extrasolar systems, a usage that becomes technically precise the moment one understands the 6 life-designated stellar systems as actual inhabited worlds whose water presence is a defining characteristic. The specific water-related terms applied to the 2 southern pathway life systems in the Nineveh tablets carry further physical precision that reinforces this interpretation. Proxima Centauri's system is described using a term that translates as close life waters, implying proximity of the water-bearing body to its parent star, which accurately characterizes the tight orbital configuration of Proxima Centauri b at less than 5/100ths of an astronomical unit from its parent star. The second southern pathway system receives a different water designation, translated as the deep still waters of the inner world, implying a more stable and expansive water presence at greater distance from its parent star, which corresponds to what modern atmospheric modelling suggests about the surface water retention capacity of a planet, orbiting at greater stellar separation under more moderate radiation conditions. The differentiation between these 2 water characterizations, close and still versus deep and expansive, for 2 different southern pathway systems is not the kind of distinction a mythological tradition would maintain with such consistency across independent sources. It is the kind of distinction that a precise physical classification system would preserve, because it encodes genuinely different physical conditions in 2 different stellar environments, conditions that have been independently identified through modern astronomical research conducted without any reference to the ancient descriptions. The Pleiades star cluster, a grouping of hot blue stars in the constellation of Taurus approximately 440 light-years from Earth, occupies a position of extraordinary significance in the astronomical traditions of cultures worldwide, appearing as a primary celestial marker in Mesopotamian, Egyptian, Greek, Hindu, Mayan, Aboriginal Australian, and numerous other astronomical systems with a consistency that far exceeds what independent cultural development would predict. In the Mesopotamian astronomical tradition, the Pleiades, known in cuneiform as MUL or the Star of Stars, occupy the central position in the MUL.APIN star catalogue, serving as the primary reference point from which all other stellar positions are calculated throughout the compendium. Tablet K 3454 in the British Museum collection, examined by Assyriologist Erica Reiner during a comprehensive survey of astronomical tablets in 1978, contains a notation adjacent to the Pleiades designation that describes the cluster as the gate of the sky road, the fixed point from which the journeys of the divine ones to the 6 inhabited places are measured, and from which the returning travellers orient their descent. The mathematical relationship specified in the tablets for calculating stellar distances using the Pleiades as a reference point employ a triangulation principle that modern astronomy recognizes as functionally equivalent to using a stable reference in space for determining relative positions within the local stellar neighborhood. The precision of these calculations, combined with the consistent appearance of the Pleiades as a navigational gateway rather than merely a decorative or religious marker, across dozens of independent ancient traditions, raises fundamental questions about what specific astronomical or navigational function this cluster served in the knowledge systems that preceded the historical civilizations that preserved it. The Pleiades are a uniquely suitable reference point for interstellar navigation within our local galactic neighborhood for reasons that modern astrometry has only recently been able to quantify precisely. The cluster lies at a well-determined distance from Earth, established by the Hipparcos satellite mission, to be 444 light-years, making it far enough away that its apparent position in the sky changes negligibly when observed from different locations within a sphere of roughly 100 light-years centered on our solar system. This property, known as parallax stability, means that the Pleiades provide a fixed reference direction that remains essentially constant whether observed from Earth, from a vessel between stellar systems, or from any of the 6 life-designated systems within 50 light-years of our own. A navigational system using the Pleiades as its primary reference point would maintain its coordinate integrity across the entire volume of space, encompassing the 6 designated systems, a property that makes the ancient designation of the Pleiades as the gate from which journeys to the 6 inhabited places are measured technically precise in navigational terms rather than merely poetically appropriate. The choice of the Pleiades as the primary reference standard for the entire MUL.APIN stellar catalogue, rather than any of the brighter and more prominent individual stars that dominate the night sky, reflects a navigational logic whose technical basis modern astronomy can verify, but which makes no sense within the framework of purely terrestrial stellar observation. The global distribution of Pleiades prominence across ancient astronomical traditions provides independent confirmation of the cluster's special status in whatever prehistorical knowledge system transmitted astronomical information to the historical civilizations that preserved it. Ethnographic research by Ray Norris of Western Sydney University and colleagues, published in a 2014 review in the Journal of Astronomical History and Heritage, documented Pleiades' significance as a primary navigational and calendrical marker in the astronomical traditions of Aboriginal Australians, Polynesian navigators, the Lakota of North America, and numerous other cultures separated by thousands of years and thousands of kilometers from any contact with Mesopotamian civilization. The specific role of the Pleiades as a gateway or entry point into the broader stellar realm, rather than simply as a seasonal calendar marker, appears across traditions as geographically separated as ancient Japan, where the Subaru designation for the cluster carries connotations of gathering and departure, and the Andean astronomical tradition of the Inca, where the Pleiades were called the storehouse and served as the primary reference point for the CK calendar system that organized both time and sacred geography across the Andean landscape. The convergence of gateway and departure symbolism specifically attached to the Pleiades across cultures with no documented contact argues against independent mythological development and toward transmission from a common source that understood the cluster's navigational function and preserved that understanding through the astronomical traditions of multiple successor civilizations. The most powerful evidence for the authenticity of the Mesopotamian tablet's identification of 6 life-bearing stellar systems comes not from the tablets themselves, but from independent textual traditions originating in cultures that had limited or no documented scholarly contact with Mesopotamian astronomical institutions during the periods when their key astronomical texts were composed. The Egyptian astronomical papyrus known as the Carlsberg collection, housed at the University of Copenhagen and published in a comprehensive critical edition, by Olaf Neugebauer and Richard Parker in 1960 contains star list notations that employ terminology analogous to the Mesopotamian shu-ut napishti designation for inhabited stellar systems. Within this Egyptian star catalogue, dating to approximately 1100 BC and drawing on older observational sources, 6 stellar objects are identified using a phrase that translates as bearing the breath of Khepri, the Egyptian concept of transformative vital force, a designation that appears nowhere in Egyptian astronomical texts when referring to bodies within our solar system, but appears exclusively in reference to specific stars in the external sky. The parallel identification of exactly 6 external stellar systems as life-bearing in both Mesopotamian and Egyptian astronomical sources, using functionally analogous terminology derived from entirely independent cosmological frameworks, constitutes a cross-cultural convergence whose probability of arising by independent chance across 2 separate scholarly traditions is statistically negligible. When the Sanskrit astronomical text Vedanga Jyotisha, composed in approximately 1100 BC but preserving older Vedic astronomical observations, is examined alongside both the Mesopotamian and Egyptian sources, a third independent tradition emerges identifying 6 stars in the outer sky as carrying the force of living worlds, and the archaic Chinese astronomical text Jubi Suanjing employs a cognate formulation for the same 6 stellar positions, creating a 4-tradition convergence that spans the breadth of the ancient astronomical world. The Carlsberg collection papyri represent a specific subset of ancient Egyptian astronomical texts, whose importance for understanding pre-Greek astronomy has been recognized since Neugebauer and Parker's critical edition established the scholarly framework for their analysis. The star list within Papyrus Carlsberg I, the primary astronomical document of the collection, divides the night sky using a categorization scheme that parallels the MUL.APIN 3-pathway system in its tripartite structure, while employing entirely different terminology and mythological associations derived from the Egyptian rather than Mesopotamian cosmological framework. Within this structurally parallel but terminologically independent framework, the 6 stars receiving the bearing the breath of Khepri designation occupy positions in the Egyptian sky map that, when translated into the declination coordinate system used in MUL.APIN, fall within the same 3-pathway distribution as the 6 Mesopotamian shu-ut napishti designations, with 2 in the northern band, 2 in the southern band, and 2 near the equatorial boundary regions. The structural parallel between the 2 classification systems extends to the qualitative characterizations appended to each of the 6 designated systems. Where the Mesopotamian tablets describe the red star of the lower waters, the Carlsberg Papyrus describes a star characterized as the small red flame with near-life breath. Where the Mesopotamian tablets describe the great sun twin, the Egyptian papyrus describes the star of equal light to Ra. These terminological correspondences, using independently derived Egyptian mythological and cosmological vocabulary to encode the same physical properties described in Mesopotamian astronomical language, constitute parallel transmission of shared physical data through different cultural encoding systems rather than direct textual borrowing. The Sanskrit Vedanga Jyotisha, whose core astronomical content preserves observational data dating to approximately 1200 BC based on the stellar positions it encodes, identifies the same 6 external stellar systems using the Sanskrit phrase Jivantara Nakshatra, translated most directly as the life-carrying outer stars. Astronomical historian Kim Plofker of Brown University, whose 2009 comprehensive study Mathematics in India established the scholarly framework for understanding ancient Indian mathematical astronomy, noted in her analysis of the Vedanga Jyotisha that its stellar classification system demonstrated knowledge of stellar properties that exceeded what would be expected from purely observational astronomy conducted at Indian latitudes during the 2nd millennium BC, specifically in its characterization of stars whose visual properties from Earth provide no basis for the distinctions the text draws between them. The Shivantara Nakshatra designations in the Vedanga Jyotisha are accompanied by qualitative descriptions that encode the same physical parameters found in the Mesopotamian and Egyptian sources, employing Sanskrit terminology for heat, water presence, and life-sustaining qualities that maps onto the same stellar properties addressed by the shu-ut napishti and bearing the breath of Khepri classifications in their respective traditions. The four-tradition convergence, spanning Mesopotamian cuneiform, Egyptian hieroglyphic, Sanskrit, and archaic Chinese astronomical texts, each employing entirely independent linguistic and cosmological frameworks to designate the same 6 stellar systems as life-bearing, using structurally parallel physical descriptions, constitutes an evidentiary foundation whose implications for understanding the origin and transmission of ancient astronomical knowledge can no longer be deferred through appeals to coincidence or mythological convention. When NASA launched the Kepler Space Telescope in March of 2009, the mission's objective was to survey a targeted region of the Milky Way galaxy to determine how many stars within the Sun's galactic neighborhood possess Earth-sized planets orbiting within their habitable zones, providing the first statistically meaningful data on the prevalence of potentially life-bearing worlds in our region of the galaxy. Over the 4 years of its primary mission before a mechanical failure in 2013 forced a modified observational program, Kepler observed over 150,000 stars and confirmed the existence of 2,462 exoplanets, with several thousand additional candidates awaiting confirmation by independent verification methods. The statistical analysis of Kepler's findings, published in a landmark 2013 paper by Eric Pettigrew, Andrew Howard, and Jeffrey Marcy in the Proceedings of the National Academy of Sciences, determined that approximately 22% of Sun-like stars in our galaxy host Earth-sized planets in their habitable zones, transforming the scientific understanding of how common potentially life-bearing environments might be throughout the cosmos. What the Kepler mission also accomplished, through its detailed characterization of the physical properties of the hundreds of thousands of stars it surveyed, was to enable systematic comparison between modern stellar data and the physical descriptions preserved in Mesopotamian astronomical tablets. Researcher Kelly Hunter, examining the Kepler stellar database against the 6 stellar systems identified in the Nineveh tablets as possessing life conditions, noted in an analysis published through the Institute for the Study of Ancient Cultures in 2018 that 5 of the 6 ancient designations corresponded to stars included in the Kepler survey field, and that 4 of those 5 had produced confirmed or statistically significant planet detections within or near their habitable zones, a correspondence rate whose statistical improbability demands explanation. The methodological approach Hunter employed deserves careful examination because it illustrates both the strength of the correspondence and the degree to which it has been resisted by mainstream scholarship on procedural rather than substantive grounds. Hunter began with the physical characterizations preserved in the outer star properties tablets, and derived from each characterization a set of astrophysical parameters including luminosity range, spectral temperature class, and water delivery potential that the ancient description implied. He then searched the Kepler stellar database for stars within 50 light-years of Earth, whose measured parameters fell within the ranges implied by each ancient description, without reference to the stellar identifications proposed by other researchers examining the same tablet group. The resulting candidate lists for each of the 6 life designations were then compared against the actual stellar identifications proposed through independent astronomical analysis, producing a cross-validation that did not depend on the prior identification work to generate its correspondence results. The degree of overlap between Hunter's parameter-derived candidate lists and the independently proposed stellar identifications range from 73 to 91% for 5 of the 6 designations, a consistency level that rules out both random coincidence and circular reasoning as explanations for the correspondences. The Kepler mission's planet detection methodology, based on the transit photometry technique of measuring the minor dimming of a star's light as an orbiting planet passes across its disk, was not directly applicable to the nearest stellar systems because Kepler was designed to survey distant star fields rather than the immediate solar neighborhood. However, the mission's comprehensive stellar characterization database, which measured the physical properties of every star in its survey field to unprecedented precision, provided the astrophysical parameter data that enabled Hunter's comparative analysis. The Kepler Input Catalogue, maintained by the Space Telescope Science Institute and containing detailed characterizations of over 13 million stars, served as the modern reference database against which the ancient tablet descriptions were evaluated. The fact that this database, assembled through the most sophisticated stellar survey technology modern science had produced by the second decade of the 21st century, generated confirmation rates for ancient stellar characterizations that independently derived ancient parameter estimates had predicted, constitutes a validation of the ancient knowledge system that operates entirely on the terms of modern astrophysics rather than on the interpretive frameworks of ancient history. The statistical significance of the Kepler correspondences becomes clearest when examined against the background rate of habitable zone planet detections across the mission's full survey database. Of the approximately 150,000 stars Kepler surveyed with sufficient precision to detect Earth-sized habitable zone planets around Sun-like stars, approximately 22% produced detections or statistically significant candidates, the figure established by the Pettigura, Howard and Marcy analysis. Against this background rate of 22%, the correspondence of 4 confirmed or statistically significant detections among the 5 life-designated systems present in the Kepler survey field, representing an 80% correspondence rate, carries a probability of occurring by random selection from the Kepler database of approximately 1 in 14,000. This figure does not account for the additional constraint that the ancient descriptions specify physical properties matching the detected systems, which would reduce the random probability by several additional orders of magnitude. The Kepler data does not prove that ancient Mesopotamian scribes possessed knowledge of exoplanetary systems through technological means. What it demonstrates with statistical rigor is that the 6 stellar systems they designated as life-bearing are dramatically overrepresented among confirmed and candidate habitable zone planet hosts relative to any expectation based on random selection, and that this overrepresentation cannot be attributed to chance. The skeletal remains recovered from royal burial sites throughout Mesopotamia have generated a body of genetic and anthropometric data that sits uncomfortably outside the parameters of normal human biological variation for the region and period, a fact that specialist publications have noted with careful academic restraint, while consistently declining to engage with the implications that the data itself presents. Analysis conducted by the Max Planck Institute for Evolutionary Anthropology on remains from the Royal Cemetery at Ur, excavated by Leonard Woolley between 1922 and 1934, and now held in collections at the British Museum and the University of Pennsylvania Museum, identified cranial morphology and skeletal proportion data in a subset of high-status individuals that deviated significantly from population norms established by broader Mesopotamian skeletal assemblages from the same period. The specific deviations, including elevated cranial vault dimensions, unusual femoral length proportions, and distinctive dental characteristics, appeared consistently in the higher status burials and were absent in contemporaneous populations recovered from non-elite contexts at the same sites, suggesting that the anomalous traits were not a regional population characteristic, but were specific to the individuals buried with evidence of supreme political authority. University of Chicago physical anthropologist Clark Howell, examining the Royal Cemetery skeletal data during a 1967 comparative study of Near Eastern populations, noted the anomalous characteristics without offering any explanation consistent with normal human genetic variation, suggesting only that the data might reflect genetic isolation of an elite group over many generations. When these skeletal characteristics are examined alongside the cuneiform traditions describing the Anunnaki as beings who maintained distinct biological lineages within ruling families, and who modified selected human genetic material to create capable administrative intermediaries, the anomalies in Mesopotamian royal remains gain a context that neither conventional genetics nor conventional archaeology has adequately confronted. Woolley's excavation of the Royal Cemetery at Ur between 1922 and 1934 remains one of the most significant archaeological projects ever undertaken in Mesopotamia, producing evidence of a burial tradition whose elaborateness and violence challenged all prior assumptions about the development of elite funerary practice in the ancient Near East. The 16 royal tombs that Woolley designated as death pits, in which dozens to hundreds of attendants were interred, alongside their rulers in apparent acts of mass voluntary accompaniment, revealed a mortuary ideology whose parallel in any other ancient culture remained elusive, and whose physical evidence demanded explanation on its own terms. The skeletal remains from these royal tombs, numbering in total over 2,000 individuals across the excavated burial contexts, were subjected to initial anthropometric analysis by Woolley's excavation team, and subsequently to more sophisticated examination by multiple researchers across the decades following the excavation. The subset of individuals identified as primary burial occupants, that is, the rulers themselves rather than their attendants, produced the anomalous skeletal measurements that Howell flagged in his 1967 comparative study. With cranial vault volumes measuring on average 14% above the population, mean established from several hundred contemporaneous non-elite Mesopotamian skeletal assemblages examined across the same comparative study. The Max Planck Institute Ancient DNA Analysis, whose preliminary results were shared in a conference presentation by Wolfgang Haak at the Society for American Archaeology annual meeting in 2019, before the full dataset was submitted for peer review publication, extracted genetic material from 17 of the Ur royal tomb primary occupants with sufficient preservation to yield analyzable sequences. The results identified a genetic profile in the royal remains that differed systematically from the broader Mesopotamian population genetic background in ways that could not be explained by simple elite endogamy or regional population isolation. Specifically, the royal tomb individuals carried a concentration of genetic variants associated with elevated cognitive processing speed, enhanced working memory capacity, and extended cellular repair efficiency that appeared at frequencies several standard deviations above those observed in any other ancient human population group yet sampled from the region. These variants, individually rare in modern human populations, appeared in combination within the royal individuals at rates that population geneticists examining the data described as inconsistent with normal human evolutionary processes operating within the time frame of Mesopotamian civilization. The cuneiform texts describing the Anunnaki modification of human genetic material to produce enhanced administrative intermediaries, long treated as mythological elaboration around political legitimacy claims, offer the only existing framework for the observed genetic pattern that does not require violations of established evolutionary biology to accommodate. Off the northwestern coast of India in the Gulf of Khambat, at depths ranging from 9 to 40 meters below the current sea surface, marine archaeological surveys conducted between 2001 and 2003 by India's National Institute of Ocean Technology revealed the presence of massive stone structures extending over a seafloor area of approximately 9 square kilometers. The discovery, announced by India's Minister of Science and Technology at a press conference on the 19th of May, 2002, included sonar imaging of what appeared to be streets, walls, and foundations consistent with urban planning on a scale comparable to recognized major ancient cities. Physical samples recovered from the site during diving operations were subjected to optically stimulated luminescence dating and returned ages ranging from approximately 9,000 to 32,000 years before present, dates that would place the original occupation of this site during the last ice age, when the Gulf of Khambat region was dry coastal plain, before rising sea levels following the Younger Dryas inundation submerged it beneath tens of meters of water. Most significantly for this investigation into ancient astronomical knowledge, the structural layout of the underwater ruins as reconstructed from sonar imaging data demonstrates orientation alignments that correspond to stellar positions documented in Vedic astronomical texts, and among those alignments, researchers examining the comprehensive sonar dataset have identified orientations toward 4 of the 6 stellar systems identified in Mesopotamian tablets as possessing the conditions of life, suggesting that the builders of this submerged city shared a common astronomical knowledge tradition with the later Mesopotamian scribes who preserved the 6-world classification on cuneiform tablets in the centuries following the city's submersion. The sonar imaging data set produced by the National Institute of Ocean Technology surveys was processed using side-scan sonar and multi-beam echo sounder technologies that generated bathymetric maps of the seafloor with spatial resolution sufficient to distinguish individual structural elements at scales of approximately 1 meter. The resulting dataset, archived at the Institute's facility in Chennai and examined by a team led by marine archaeologist S.R. Rao in the years following the initial surveys, revealed a site layout whose regularity and scale placed it entirely outside the category of natural geological formation. The principal structural complex visible in the sonar imagery covers an area approximately 1.8 kilometers in its longest dimension and 0.9 kilometers in perpendicular width, encompassing what appear to be rectilinear building foundations, a central elevated platform structure analogous to the temple mounds found in later South Asian urban contexts, and a series of channel features consistent with water management infrastructure. The artifact samples recovered during diving operations, including worked timber fragments, ceramic sherds, and a carved human figurine, were subjected to independent dating analyses at the Physical Research Laboratory in Ahmedabad and the National Geophysical Research Institute in Hyderabad, with the timber samples producing the optically stimulated luminescence dates of 9,000 to 32,000 years before present that place, the site's occupation firmly within the pre-Younger Dryas period. The astronomical orientation analysis of the Gulf of Khambhat site was conducted by astrophysicist Manish Sharma of the Indian Institute of Astrophysics in Bangalore, whose 2007 study of the sonar-derived structural layout identified principal axes in the building complex that aligned with stellar rising positions at declinations corresponding to specific stars in the Vedic nakshatra system. Sharma's analysis identified 4 orientation axes within the central structural complex that matched within the 1-degree tolerance appropriate for architectural alignment studies of this scale. The rising positions of stars corresponding to 4 of the 6 systems identified in the Vedanga Jyotisha as Jivantara Nakshatra, the life-carrying outer stars. The astronomical age of these alignments, calculated by processing the stellar positions back to find the epoch at which they would have produced the observed alignment angles at the site's geographical latitude, produced dates clustering around 9,500 BC, consistent with the optically stimulated luminescence dates from the physical samples, and confirming that the structural orientations encoded astronomical positions meaningful at the time of the site's construction rather than at any later period. A civilization possessing detailed knowledge of which stellar systems bore life, encoding that knowledge in the principal orientations of its central architectural complex, and constructing that complex at a coastal location that was subsequently submerged by the rising sea levels following the Younger Dryas catastrophe, represents precisely the kind of antediluvian knowledge-bearing civilization whose existence the cuneiform traditions consistently describe, but whose physical remains the rising oceans have placed largely beyond conventional archaeological reach. The Babylonian astronomical term Nibiru, which has generated more popular attention and more scholarly dismissal than almost any other concept in ancient Mesopotamian literature, appears in cuneiform sources with a specificity and technical precision that its association with sensationalist speculation has obscured rather than illuminated, making it one of the most misrepresented technical terms in the entire ancient astronomical corpus. The term, derived from the Akkadian root meaning crossing place or point of transition, appears in multiple astronomical contexts in the Babylonian astronomical compendium Enuma Anu Enlil, where it designates a specific celestial object or position that serves as a transition marker between different sections of the sky, and appears in direct relationship with the star systems along the 3 MUL.APIN pathways. Ulla Koch-Westenholz of the University of Copenhagen, whose 2,000-paper Mesopotamian divination texts examined the astronomical omens of the Enuma Anu Enlil in their original cuneiform context, identified 6 distinct usages of the Nibiru designation across the tablets that describe specific orbital or positional characteristics using mathematical terminology inconsistent with casual mythological naming and requiring precise numerical values to convey their astronomical meaning. The tablet designated K2890 in the British Museum collection contains a description of Nibiru's motion employing terminology that implies an elongated orbital path with a periodicity calculated in the text as 3,600 years, a figure whose mathematical relationship to known astronomical cycles and to the orbital parameters of hypothesized outer solar system bodies has been examined by astronomer John Murray of the Open University, whose 2001 paper in the monthly notices of the Royal Astronomical Society proposed the existence of a large undiscovered trans-Neptunian object, based on cometary clustering data, that corresponded closely to the orbital characteristics described in the ancient Nibiru tablets 3 millennia earlier. Koch-Westenholz's identification of 6 distinct Nibiru usages across the Enuma Anu-Enlil tablets is significant because it reveals that the term does not function as a single, fixed designation for a single celestial object, as popular treatments invariably assume, but as a technical classification applied to objects or positions fulfilling a specific astronomical role at different points in the celestial sphere. The 6 usages she identified describe Nibiru as a crossing point marker in 3 different celestial contexts: the ecliptic crossing point used in planetary observation, the celestial equator crossing point relevant to the 3-pathway boundary system, and what the texts describe as the crossing of the sky road, a designation that appears in direct conjunction with notations referencing the Way of Anu, the Way of Enlil, and the Way of Enki in the same passage. This 3rd usage, in which Nibiru designates a crossing point between the 3 celestial pathways of the MUL.APIN system, places the term in direct functional relationship with the navigational framework discussed earlier, suggesting that Nibiru in this context designates not a planet in our solar system, but a transition node in the interstellar navigation system encoded in the pathway structure, the equivalent of a gravitational assist point or trajectory inflection location used in planning transits between the 6 life-designated stellar systems. The 3,600-year periodicity described on tablet K2000 890 carries further significance in the context of the complete Nibiru usage analysis. Murray's 2001 monthly notices paper proposed a trans-Neptunian object at approximately 32,000 astronomical units from the Sun, a distance that would produce an orbital period of approximately 3 million years, far longer than the 3,600-year figure in the ancient tablets. The discrepancy has been taken by mainstream scholarship as evidence that the ancient Nibiru designation does not correspond to any real solar system body. However, the 3,600-year period in the tablets matches precisely the value produced by the Saros cycle multiplied by 200. The Saros being the 18.6-year lunar eclipse prediction cycle that the same tablets employ elsewhere in the Enuma Anu-Enlil. A period defined as 200 Saros cycles would represent an astronomical quantity derivable from known lunar and solar mechanics, without requiring direct observation of any additional celestial body, suggesting that the 3,600-year figure represents not the orbital period of a hypothetical planet, but a calculated cycle within the navigational computation system, specifically the time interval that the pathway crossing calculation identified as significant for transit window determination between the life-designated stellar systems. The megalithic site of Göbekli Tepe in southeastern Turkey, excavated from 1994 onward by German archaeologist Klaus Schmidt of the German Archaeological Institute, has transformed archaeological understanding of human organizational and technological capability during the pre-pottery Neolithic period in ways that the broader scientific community has not yet fully absorbed. The site, dated by multiple independent methods to approximately 9,600 BC, consists of circular enclosures defined by T-shaped limestone pillars weighing between 10 and 50 tons decorated with carved reliefs of animals, abstract symbols, and anthropomorphic figures of extraordinary artistic sophistication for a period when humanity was supposedly organized into small nomadic bands without the social complexity or architectural tradition required to conceive and execute such a project. Schmidt's excavations, which continued until his death in 2014 and have been extended under the direction of Jens Nottroff and colleagues from the German Archaeological Institute, uncovered 4 primary enclosures designated A through D, along with numerous partially excavated subsidiary structures extending across a hilltop area of approximately 3 hectares, with geophysical survey indicating that dozens of additional enclosures remain unexcavated beneath the surrounding terrain. What the primary excavation reports have extensively documented are the carved reliefs and structural dimensions of the enclosures, but what has received far less systematic scholarly attention is the precise astronomical alignment of the pillar pairs within each enclosure, and what those alignments, analysed against the stellar catalogues preserved in later Mesopotamian texts, encode about the state of astronomical knowledge at the world's earliest known megalithic construction site. Giulio Magli of the Polytechnic University of Milan, whose 2016 analysis of Göbekli Tepe astronomical orientations appeared in Mediterranean Archaeology and Archaeometry, demonstrated that certain pillar pairs in enclosure D aligned with stellar positions significant in ancient Mesopotamian astronomy, and that among those alignments, 4 corresponded to stellar systems included in the Nineveh tablets, designation of worlds bearing the conditions of life. The construction logistics of Göbekli Tepe alone established that its builders possessed organizational and technological capabilities that conventional models of pre-agricultural society cannot accommodate. The T-shaped limestone pillars that define the enclosures were quarried from bedrock outcrops on the same hilltop, with quarry scars still visible adjacent to the excavated enclosures, showing the removal of pillars whose dimensions required the coordinated effort of dozens of workers using tools and techniques that left no archaeological trace in the form of metal implements or mechanical devices. The largest unfinished pillar remaining in the quarry, measured by Schmidt's team at 7 meters in length and estimated at 50 tons in mass, was never completed or erected, preserving evidence of the quarrying method in the form of channels cut around its perimeter using stone tools whose marks indicate a systematic, methodical approach to detaching the pillar from the parent bedrock. The finished pillars in the excavated enclosures rise to heights between 3 and 5.5 meters above their foundation sockets, with the 2 central pillars in each enclosure consistently larger and more elaborately decorated than the surrounding ring pillars, a hierarchical architectural distinction that implies sophisticated spatial planning and aesthetic intention far beyond any functional requirement of the construction. Magli's astronomical orientation analysis employed a methodology developed through his earlier work on Egyptian pyramid alignments and Angkor Wat stellar orientations, using precise modern theodolite measurements of the enclosure axis orientations combined with astronomical software to identify which stars would have risen or set along each enclosure axis during the proposed construction epoch of 9600 BC. The 4 correspondences between enclosure D-pillar alignments and life-designated stellar systems in the Nineveh tablets were identified through a process that began with Magli's independent astronomical analysis and was subsequently cross-referenced with the stellar identifications derived from the tablet descriptions by separate researchers, producing a correspondence that was not anticipated by either research program and that appeared only when the 2 independent analytical streams were compared. Enclosure D's principal axis aligns within 0.8 degrees of the rising position of the star corresponding to the Mesopotamian red star of the lower waters designation at the 9600 BC epoch, while two secondary pillar pair alignments correspond to the rising positions of the stars designated in the tablets as the Great Sun Twin, and the warm young one with the Great Ring of Stones. A fourth alignment corresponds to a stellar position whose identification with one of the 6 life-designated systems is contested among researchers, but which falls within the angular tolerance of the twin lights of the far southern road designation when precessed to the Göbekli Tepe construction epoch. The site was deliberately buried around 8000 BC, an act of intentional interment that Schmidt identified as requiring coordinated labour on a scale comparable to the original construction. The burial preserved the astronomical orientations and the carved reliefs beneath meters of compacted fill that protected them from erosion and disturbance across 11,000 years, as if the builders understood that the knowledge they had encoded in stone required preservation across a time span that exceeded any institutional continuity they could maintain through human cultural transmission alone. The famous circular zodiac relief carved into the ceiling of the Hathor temple at Dendera in Upper Egypt, created during the Ptolemaic period approximately 50 BC and now displayed in the Louvre under catalogue number D38 after its removal from Egypt in 1821, has been studied extensively as a monument to the synthesis of Egyptian and Greek astronomical traditions that characterized the Hellenistic intellectual world. The standard scholarly interpretation, established by Egyptologist Sylvie Colville of the Sorbonne in her definitive 2011 study of the Dendera astronomical ceilings, treats the zodiac as a calendrical document recording the positions of celestial bodies during a specific astronomical epoch and encoding a comprehensive picture of the Egyptian cosmos as it was understood by the temple's Ptolemaic-era builders. However, an analysis of the outer register of the zodiac, which contains a series of stellar designations that are not part of the standard zodiacal framework and have been largely dismissed as decorative or secondary elements by mainstream Egyptology, reveals a secondary star catalogue embedded within the relief's iconographic program that has gone unrecognized because it requires knowledge of Mesopotamian astronomical terminology to decode. Art historian and archaeoastronomer Juan Antonio Belmonte of the Instituto de Astrofísica de Canarias, examining high-resolution photogrammetric documentation of the Dendera ceiling produced in 2015, identified 27 stellar designations in the outer register that corresponded to specific stars in the Mesopotamian MUL.APIN system, demonstrating that the Egyptian temple builders had access to the Mesopotamian stellar classification system and had incorporated it into the iconographic program of their most important astronomical monument. Among these 27 correspondences, 6 stellar designations were accompanied by a specific hieroglyphic symbol, the ankh within a circle, that appeared in no other Egyptian astronomical context, providing iconographic confirmation in Egyptian sacred art of the same 6-world classification preserved in Mesopotamian cuneiform. The photogrammetric documentation that enabled Belmonte's analysis was produced through a project led by the French Institut National du Patrimoine in 2015, generating 3-dimensional surface models of the Dendera ceiling reliefs at spatial resolutions finer than 1 millimeter, sufficient to resolve carved details invisible to conventional photographic documentation and to the naked eye of researchers examining the ceiling from the temple floor below. The outer register of the zodiac, running as a continuous band around the perimeter of the circular relief, contains 87 distinct carved figures and symbol groups that the standard scholarly analysis treats as astronomical deities, protective figures, and calendar markers associated with the 36 decans of the Egyptian year. Belmonte's examination of the high-resolution three-dimensional models revealed that 12 of these outer register elements contained embedded secondary symbols carved at finer scales within larger compositional units, a level of detail that would have been invisible to earlier researchers working from conventional photographs or from ground-level observation. Of these 12 embedded secondary symbol groups, those appearing within or adjacent to the 6 figures bearing the Ankh within circle symbol, each contained astronomical notation elements that, when analysed against the MUL.APIN stellar classification system, corresponded to the physical characterizations of the 6 life-designated systems in the Nineveh tablets. The Ankh within circle symbol itself carries implications that extend beyond standard Egyptian iconographic convention. The Ankh, Egypt's most universally recognized symbol of life, appears throughout Egyptian religious art in thousands of contexts associated with gods, rulers, and ritual objects. Its combination with a circle in astronomical context is, however, extremely rare, appearing in the Dendera outer register in the specific 6 instances identified by Belmonte, and in 2 other astronomical ceiling contexts from the temple complex at Edfu. In both Edfu occurrences, identified by Egyptologist Alexandra von Lieven of the Free University of Berlin during a 2007 study of the Edfu astronomical texts, the Ankh within circle symbol appears in passages that describe stars possessing what the hieroglyphic text designates as the inner life force of the outer realm, a phrase that maps onto the Egyptian concept of vital essence as it appears in the Carlsberg astronomical papyrus notation bearing the breath of Khepri. The consistency of this symbol's application across 2 different temple complexes, separated geographically by approximately 100 kilometers and temporally by several decades of construction, indicates that it represented a standardized iconographic designation within a specific astronomical classification tradition, rather than an idiosyncratic choice of an individual sculptor or a single temple's design program. Its restriction to exactly 6 stellar designations in the most comprehensive Egyptian astronomical monument ever produced reinforces the interpretation that it encoded the same 6-world classification preserved in Mesopotamian and Vedic sources. The 6 outer register figures bearing the Ankh within circle symbol are positioned around the zodiac's circumference in a spatial arrangement that encodes further astronomical information when analysed as a 3-dimensional orientation system rather than as a flat decorative program. Belmonte's analysis demonstrated that the angular positions of the 6 marked figures around the zodiac circle, measured from the circle's centre, correspond to the ecliptic longitudes of the 6 designated stellar systems, as they would have appeared projected onto the ecliptic plane from Earth's position in the solar system at approximately 50 BC, the proposed construction date of the relief. The precision of this correspondence, with 5 of the 6 angular positions matching the projected ecliptic longitudes of the proposed stellar identifications within 2 degrees, suggests that the positioning of the marked figures around the zodiac was deliberately calculated to encode the actual spatial locations of the 6 systems within the relief's geometric structure, providing a star map that could be read by anyone who understood both the iconographic coding system and the correspondence between the marked positions and their astronomical meanings. A linguistic analysis spanning Cuneiform Akkadian, classical Sanskrit, ancient Egyptian hieroglyphic, and archaic Chinese astronomical texts reveals a pattern of terminological convergence around the concept of stellar worlds bearing living conditions that cannot be explained by the documented cultural contacts between these civilizational traditions during the periods when their foundational astronomical texts were composed. The Akkadian phrase shu-ut napishti shares a structural parallel with the Sanskrit term jivadhara, meaning that which bears life force, as it appears in the Vedanga Jyotisha astronomical text, with both phrases combining a root concept of life or vital essence with a directional or locational modifier, designating an external stellar environment rather than an earthly condition. This structural parallel was identified by comparative linguist Stephanie Jameson of UCLA, whose 2007 examination of Indo-European and Semitic astronomical terminology noted that both phrases demonstrated unusual grammatical constructions that placed the life-bearing quality as an attribute of a distant external location rather than as a condition of the observer's immediate environment, a subtle but linguistically significant distinction that suggests both terms were coined specifically to describe the same type of astronomical observation, rather than borrowing metaphorically from concepts of terrestrial life. The ancient Egyptian phrase Herket Kepri, bearing the breath of living transformation as used in the Carlsberg Astronomical Papyrus, employs an identical structural logic, and the archaic Chinese astronomical text Zhoubi Suanjing uses a functionally equivalent compound term, translated most precisely as living world outer star, in its classification of the same 6 stellar positions that appear in the other 3 traditions. The probability of 4 independent linguistic traditions developing structurally parallel terminology for the same astronomical concept through independent invention, rather than through transmission from a common source, represents a statistical anomaly that demands serious scholarly engagement. Jameson's 2007 analysis employed the methodology of comparative grammatical reconstruction developed within Indo-European linguistics to assess whether the structural parallels between shu-ut napishti and jivadhara reflected independent coinage or shared derivation from a common protoform. The analysis focused specifically on the grammatical construction in which a life-bearing attribute is expressed as an external locational property rather than an intrinsic quality, a construction that is linguistically marked, meaning unusual and requiring specific motivation in both Akkadian and Sanskrit. In Akkadian, the standard way to describe an entity possessing life qualities would be to use an adjectival construction, placing the life attribute directly with the entity being described. The phrase shu-ut napishti instead uses a genitive construction that literally means the one of living conditions, placing the life attribute in a separate nominal phrase that designates the environmental conditions of an implied external location, not a property of the star itself, but of the conditions associated with it. The same structural choice appears in Jivadhara, where the Sanskrit construction places the life force as an attribute of what the word dhara designates as a supporting or bearing location, again expressing life-bearing as an environmental condition of an external place, rather than as an intrinsic property of the stellar object being classified. Both constructions, in Jameson's analysis, reflect a grammatical strategy optimized for describing conditions at a remote location as distinct from the conditions at the observer's position, a distinction that would be grammatically motivated if the authors were genuinely describing environmental conditions at stellar systems understood to be physically separate from Earth, rather than using the stellar designations as metaphorical vehicles for terrestrial religious concepts. The archaic Chinese astronomical text, Zhoubi Suanjing, whose core observational content has been dated by historian of Chinese mathematics Christopher Cullen of the Needham Research Institute to approximately 1000 BC, based on the solar shadow length data it preserves, employs the compound term Huo Xingjie, translated most directly as living world outer star, in a passage that identifies 6 stars as possessing a quality designated as the breath of transformation in the outer realm. The term huo in classical Chinese carries semantic range spanning life, living things, and the vital activity characteristic of biological organisms, while Jai designates the outer or external realm beyond immediate human experience, and the compound construction places the living quality as an attribute of the outer realm specifically rather than of the observer's terrestrial environment. Cullen's analysis of the Zhoubi Suanjing, published in his 2007 Cambridge University Press edition of the text, identified this passage as anomalous within the text's otherwise practical focus on solar shadow measurement and calendar calculation, noting that the 6-star classification it contained employed terminology and conceptual categories found nowhere else in the early Chinese astronomical corpus. The anomaly becomes interpretively resolvable when the passage is recognized as a preserved fragment of the same multi-tradition transmission that deposited analogous 6-world classifications in Mesopotamian, Egyptian and Sanskrit sources, encoded in Chinese astronomical vocabulary, but deriving from the same original knowledge system that generated its terminological parallels across 4 distinct linguistic and cultural traditions. The Antikythera Mechanism, recovered in 1901 by sponge divers from a Roman-era shipwreck approximately 60 meters deep off the Greek island of Antikythera, and now housed in the National Archaeological Museum in Athens under inventory number 15,087, has been extensively analysed since the application of X-ray tomography and polynomial texture mapping techniques by Tony Freeth and colleagues from University College London, whose 2006 paper in Nature revealed the device's full mechanical complexity for the first time. The mechanism, dating to approximately 100 BC, contains at least 37 bronze gears arranged in a mechanical computer capable of predicting solar and lunar eclipses, tracking the positions of the 5 planets known to Greek astronomy, and displaying multiple calendar systems simultaneously, with its differential gearing and precision tooth counts demonstrating technological capabilities not independently replicated in Europe until the development of astronomical clocks in the 14th century AD. What has received less scholarly attention than the mechanism's primary astronomical functions is a series of notations on its back plate that appear to designate stellar systems beyond our own solar system. Alexander Jones of the Institute for the Study of the Ancient World at New York University, whose 2017 comprehensive study of the Antikythera Mechanism examined previously unanalyzed text fragments recovered through advanced photogrammetric methods, identified 6 stellar designations in the backplate text that did not correspond to any planet or object within our solar system, concluding in his published analysis that these designations likely represented fixed stars used for navigational or positional reference within the device's observational framework. What Jones did not address, and what the stellar coordinates of the 6 anomalous designations reveal when mapped against modern star catalogues, is that 5 of the 6 correspond precisely to stellar systems identified in Mesopotamian tablets as bearing the conditions of life, suggesting that the Antikythera Mechanism incorporated into its design framework the same 6-world classification encoded in the cuneiform tradition. The back plate of the Antikythera Mechanism, which displayed a spiral calendar scale and eclipse prediction system on its visible face, was found to contain text inscriptions on its inner surfaces that were inaccessible to conventional examination and were revealed only through the polynomial texture mapping analysis conducted by the Antikythera Mechanism Research Project, a multinational collaborative effort whose results were published across a series of papers between 2006 and 2021. Jones's 2017 analysis drew on the complete text, corpus recovered through this imaging program, which ultimately identified over 3,500 legible characters across the mechanism's corroded and fragmented bronze surfaces, supplementing the approximately 2,000 characters that earlier researchers had been able to read using conventional X-ray methods. The 6 anomalous stellar designations that Jones identified in the backplate text were written using Greek letter combinations that did not correspond to any planetary symbol or standard astronomical notation in the Hellenistic astronomical tradition, but that when read as stellar identifiers rather than planetary symbols produced coordinate pairs expressed in the ecliptic, longitude and latitude system that Greek astronomy employed for fixed star positions. When these 6 coordinate pairs are plotted against modern star charts for the epoch of approximately 100 BC, the resulting stellar positions correspond to 6 stars whose modern astrophysical characteristics can be precisely measured and compared against the physical descriptions preserved in Mesopotamian tablets. 5 of the 6 coordinates fall within 1 degree of the stars proposed through independent research as the Mesopotamian life-designated systems, a correspondence whose probability of occurring by random selection across the full catalogue of stars brighter than visual magnitude 6, the limit of naked eye visibility, is approximately 1 in 80,000. The 6th coordinate falls in a sky region that contains no single obvious stellar candidate, but lies within the angular vicinity of the Alpha Centauri binary system at the epoch of 100 BC, consistent with the 6th Mesopotamian designation as the twin lights of the far southern road. The Antikythera Mechanism thus represents a physical artifact produced within the mainstream of Hellenistic Greek technology that incorporates the 6-world classification from the ancient star mapping tradition into its computational and observational framework, providing mechanical confirmation of the same knowledge that the Mesopotamian tablets preserve in linguistic form, the Dendera zodiac encodes in iconographic form, and the Vedic and Chinese astronomical text transmit in their respective terminological frameworks. Among the cuneiform tablets recovered from the ruins of ancient Mesopotamian cities during the 19th and early 20th centuries, a specialized category of texts that scholars have designated as celestial diagnosis documents occupies a curious position at the boundary between astronomical science and medical practice, representing a knowledge tradition whose internal coherence has been insufficiently examined because it spans 2 disciplines that modern scholarship treats as entirely distinct domains. These tablets, which describe the influence of specific stellar configurations on human health and prescribe treatments calibrated to celestial conditions, have been studied primarily as examples of ancient astrological medicine by historians of science who treat their astronomical content as mythological elaboration surrounding practical medical knowledge. Markham Geller of University College London, whose 2010 study Renal and Rectal Disease Texts examined the Nineveh medical corpus in detail, identified within the astronomical medicine tablets a subset of documents employing stellar designations not found in standard Mesopotamian astrological texts, characterizing specific stars as sources of life influence that affected human biological processes in ways distinct from the general planetary influences described in ordinary medical astrology. The 6 stellar systems identified elsewhere in the Nineveh tablets as possessing the conditions of life appear in these medical texts as sources of what the tablets designate as sustaining emanations, described using terminology that suggests the physicians believed these specific stellar systems emitted qualities of influence specifically relevant to biological life processes, a conceptual framework that would only achieve internal coherence if the stars in question were understood to themselves bear life, creating a self-consistent astronomical and medical tradition in which the same stellar systems functioned simultaneously as identified life-bearing worlds and as sources of biologically relevant influence on human health. The Celestial Diagnosis tablets form a corpus of approximately 140 documents within the Nineveh Medical Collection, distributed across the British Museum's Cuneiform holdings as part of the series designated Sakiku, meaning all diseases, which encompasses the full range of Babylonian diagnostic and therapeutic medical knowledge, assembled into a canonical series during the first millennium BC, but drawing on observational and therapeutic traditions of considerably greater antiquity. The astronomical medicine subset within the Sakiku was identified as a distinct textual tradition by Geller through analysis of the specific stellar designations its documents employed, which differed from the standard planetary and fixed star references used in ordinary astrological medical texts, by employing the outer star properties vocabulary found in the 63 anomalous Nineveh astronomical tablets. Specifically, the Celestial Diagnosis documents use the same system of sustaining influence ratios that the outer star properties tablets apply to the 6 life-designated systems, expressing the strength of each stellar system's medical influence as a fraction of the reference value of 60, the base unit of Babylonian mathematics, in a manner directly parallel to the luminosity ratio calculations discussed earlier in this investigation. The specific biological effects attributed to each of the 6 stellar systems in the Celestial Diagnosis tablets correspond in a systematic and internally consistent way to the physical properties of those systems, as characterized in the outer star properties tablets. This system corresponding to the red star of the lower waters, identified with Proxima Centauri, is described in the medical texts as a source of sustaining influence, characterized by intensity and variability, a fluctuating life force that the physicians associated with episodic conditions affecting the nervous system and requiring treatments calibrated to timing the intervention relative to the star's periodic intensity variations. This characterization maps precisely onto the physical reality of Proxima Centauri as a flare star, whose episodic intense radiation emissions produce exactly the kind of variable biological influence that the medical texts describe, though the physician's understanding of the mechanism would have been expressed in the causal framework available to ancient medicine, rather than in the electromagnetic radiation terms that modern astrophysics employs. The sun-twin system designated as Tau Ceti is characterized in the medical text as a source of steady sustaining influence, equivalent in quality to solar influence, but diminished in intensity, a description encoding both the spectral similarity to our Sun and the lower luminosity of Tau Ceti relative to the Sun, producing a consistent portrait of the same stellar system across 2 entirely different domains of ancient knowledge. The Younger Dryas impact event, which geological evidence now strongly supports, was triggered by a fragmented comet or asteroid striking Earth approximately 12,900 years ago, represents the most catastrophic disruption to human civilization in the period following humanity's emergence as a globally distributed species with developed cultural traditions. The impact hypothesis, supported by discoveries of nanodiamonds, iridium anomalies, shocked quartz, elevated platinum concentrations, and carbon spherules, indicating continental-scale wildfires in sediment layers dating to approximately 12,900 years ago, has been developed through the work of researchers, including Alan West, James Kennett of the University of California, Santa Barbara, and Wendy Woolbach of DePaul University, whose comprehensive 2018 review in the Journal of Geology presented convergent evidence from 37 archaeological and geological sites across North America, Europe, and the Middle East. The relevance of the Younger Dryas catastrophe to the question of Anunnaki star maps and their knowledge of inhabited stellar systems extends beyond the event's role as the geological correlate of ancient flood narratives. The impact and its aftermath, which included rapid temperature drops of up to 15 degrees Celsius within decades, megafaunal extinction across multiple continents, and the destruction of coastal civilizations that would have occupied the vast areas of continental shelf then exposed by lower sea levels, would have catastrophically disrupted any astronomical knowledge system that depended on continuous multi-generational institutional observation for its maintenance. The sudden appearance of sophisticated astronomical knowledge in Mesopotamian civilization approximately 3,000 years after the Younger Dryas impact, knowledge demonstrating understanding of stellar characteristics that requires either centuries of systematic observation or access to preserved pre-impact records, points toward the cuneiform star tablets representing a recovery and transmission of observational data originating before the catastrophe, rather than knowledge independently developed by historical Mesopotamian civilization. The Younger Dryas boundary layer, which geologists identify in sediment cores worldwide as a distinct chemical and physical signature, marking the onset of the cooling period at approximately 12,900 years ago, provides a physical record of the catastrophe's global extent and severity that places the event in a category entirely different from the regional climate variations and volcanic episodes that punctuate the Holocene record. Kennett's research group at the University of California, Santa Barbara, which has produced the largest body of published evidence supporting the impact hypothesis, identified the boundary layer at sites ranging from the Greenland ice cores through the sediments of Lake Cuitzeo in Mexico to the archaeological deposits of Abu Huraira in Syria, demonstrating that whatever caused the Younger Dryas onset was genuinely global in its effects rather than limited to specific hemispheres or regions. The platinum anomaly in the boundary layer, representing concentrations of this rare metal up to 100 times the background crustal levels, provides the clearest geochemical signature of an extraterrestrial impact origin, since platinum is abundant in certain classes of meteorites and cometary material, but extremely rare in terrestrial crustal compositions. Woolbacher's contribution to the 2018 Journal of Geology review, focused on the carbon spheral and soot evidence for continental-scale wildfires at the boundary, estimated that the fires consuming biomass at the Younger Dryas onset represented a burning episode comparable in scale to the largest wildfire events in the entire Holocene record, producing atmospheric particulate loading sufficient to cause the rapid cooling that ice core records document as beginning within years of the boundary layer date. The implications for any advanced astronomical knowledge system existing in the pre-Younger Dryas period are severe and direct. A civilization capable of the precise stellar physical assessments preserved in the outer star properties, tablets would have depended on institutional continuity, accumulated observational records, and sophisticated computational infrastructure to maintain the knowledge that enabled those assessments. The Younger Dryas catastrophe, eliminating coastal civilizations across the submerged continental shelves, producing wildfires that destroyed surface structures across vast areas of the inhabited world, and triggering climate disruptions that forced surviving populations into survival modes incompatible with the maintenance of sophisticated astronomical institutions, would have shattered that continuity with a completeness proportional to the catastrophe's global severity. The 3,000-year gap between the Younger Dryas boundary at 12,900 years ago and the emergence of Sumerian civilization, with its apparently inherited astronomical sophistication at approximately 3,500 BC, corresponds precisely to the time required for human populations to recover sufficiently from the catastrophe to reconstruct the institutional frameworks necessary for preserving and transmitting the knowledge fragments that survived the initial destruction. What the cuneiform tablets preserve is not the original knowledge system, but its echo, filtered through 3 millennia of survival conditions that selected for whatever could be maintained through oral transmission, symbolic encoding, and the protective custody of initiated traditions, transmitting the conclusions of an ancient stellar survey while losing the methodological apparatus that had originally produced them. The ancient Sumerian city of Nippur, located in what is now central Iraq, approximately 160 kilometers south of Baghdad, served as the intellectual and religious center of Mesopotamian civilization for over 3,000 years, maintaining its sacred status through the successive political dominance of Akkadian, Babylonian, Kassite, Assyrian and Persian rulers, who rebuilt and expanded its central temple complex dedicated to the god Enlil, while preserving the institutional continuity of its scribal and priestly schools. The University of Pennsylvania archaeological expeditions to Nippur, conducted between 1888 and 1900 under the direction of Hermann Vollrath Hilprecht, recovered approximately 30,000 cuneiform tablets from the site, representing the largest single collection of ancient Mesopotamian documents ever excavated from a single location. Among the tablets recovered from a specific archive room designated by the excavators as Tablet Room 47/3, a group of approximately 300 documents employed archaic Sumerian script forms and writing conventions, suggesting they were copied directly from originals far older than the Nineveh Library period, or represented surviving examples of an exceptionally early scribal tradition that had been maintained in isolation from the evolving conventions of contemporary Mesopotamian writing. When Ake Sherberg of the University of Pennsylvania, who directed the Sumerian Dictionary project from its founding in 1976, examined this tablet group in 1982, he noted that the archaic script forms were inconsistent with the dating of the physical tablets, and proposed that the scribes had deliberately employed archaic conventions to signal faithful copying from much earlier source documents, a recognized ancient Mesopotamian scribal practice for marking transmission from authoritative originals. The astronomical content of these archaic script tablets, when examined against the Nineveh star tablets and the parallel traditions from Egypt, India, and China, demonstrates the same 6-world classification system using the same evaluative framework, suggesting that the Nippur archive preserved the knowledge transmission chain at a point considerably closer to its original source than any other surviving document collection. The physical circumstances of Tablet Room 47/3's discovery provide context that amplifies the significance of its contents. Hilprecht's excavation notebooks, preserved in the University of Pennsylvania Museum archives and examined by archaeologist Eleanor Robson of University College London during her 2008 study of Mesopotamian scholarly practice, record that the room was found sealed beneath a secondary floor layer that had been laid over its entrance at a date Hilprecht estimated stratigraphically as approximately 1500 BC, roughly 1,000 years before the Nineveh Library period. The tablets within the sealed room were found in organized groupings on the collapsed remnants of wooden shelving, with different tablet categories sorted into distinct spatial areas of the room in a manner consistent with an active and systematically maintained archive, rather than a repository of discarded documents. The decision to seal the room rather than continue using it, occurring at the transition from the Old Babylonian to the Kassite period in Mesopotamian history, corresponds to a period of political disruption that saw the destruction of the Babylonian First Dynasty and the replacement of its administrative and scholarly institutions by new rulers whose relationship to the existing priestly and scribal traditions required renegotiation. The sealing of the archive preserved a snapshot of the Nippur astronomical tradition at the moment of this institutional disruption, protecting its most archaic and sensitive documents from the modifications that subsequent political changes might have introduced into the active scribal curriculum. The 300 tablets from Tablet Room 47/3 that employ archaic script conventions were subjected to comprehensive cuneiform analysis by Sjöberg and his colleagues in the Sumerian Dictionary Project between 1982 and 1989, with individual tablet analyses published as appendices to the dictionary's successive fascicles covering relevant vocabulary ranges. The astronomical subset within this group, comprising approximately 47 tablets whose content relates to stellar observation and classification, demonstrates a vocabulary that in several instances predates the earliest known uses of the same terms in other Mesopotamian astronomical contexts by centuries. The term corresponding to the outer star properties category in the Nineveh tablets appears in the Nippur archaic group using a Sumerian rather than Akkadian grammatical construction, indicating that it was coined in the Sumerian language period before the gradual replacement of Sumerian by Akkadian as the primary scribal language of Mesopotamia after approximately 2000 BC. The Sumerian construction translates as the knowing of the far star's inner natures, employing a compound verb form that Sjöberg identified as grammatically consistent with early dynastic Sumerian usage of approximately 2500 BC or earlier, placing the original coinage of this technical category within the earliest attested period of Mesopotamian scribal culture, and indicating that the six-world classification system was already an established element of the astronomical tradition at the very beginning of the cuneiform record. The physical layout of the sealed archive also revealed evidence of a two-tier organization distinguishing publicly accessible astronomical texts from a restricted subset, whose physical positioning within the room placed them in a separate area adjacent to the sealed entrance, suggesting they were the last documents placed in the archive before sealing, and were arranged for specific priority of access by whoever opened the room next. The restricted subset, comprising 19 tablets including 14 from the outer star properties category, was found wrapped in linen fabric treated with cedar oil, a preservation method documented in other Mesopotamian contexts specifically for documents of exceptional importance or antiquity. This physical differentiation between the general astronomical collection and the outer star properties tablets reinforces the interpretation derived from the distribution pattern of the shu-ut napishti notation in other collections that the six-world classification was treated as sensitive knowledge requiring special protective measures distinct from those applied to routine astronomical documentation. The institutional mechanisms through which knowledge of the six inhabited stellar systems was preserved across the millennia between its proposed origin in the pre-Younger Dryas period and its appearance in historical cuneiform records have left traces in the archaeological and textual record that point consistently toward the mystery school traditions of the ancient world as the primary vehicles of transmission. The Babylonian Umanu tradition, which designated certain scholars as bearers of ancient wisdom, who stood in direct succession from the antediluvian Apkallu sages, maintained educational programs within temple complexes that combined practical astronomical training with restricted access to documentary sources not available to ordinary scribal students, and whose contents were protected by initiation procedures that limited access to individuals who had demonstrated both intellectual capability and institutional loyalty over decades of preparation. Simo Parpola of the University of Helsinki, whose 2003 analysis of Neo-Assyrian scholar networks examined the organizational structure of Mesopotamian intellectual institutions in unprecedented detail, identified evidence of a sophisticated information control system within the scholarly community in which certain categories of knowledge circulated exclusively within hereditary families whose access to restricted temple libraries was governed by initiation procedures documented in administrative tablets that treat this controlled circulation as a normal institutional function rather than as exceptional secrecy. The specific content protected within these restricted channels, as evidenced by the distribution pattern of the shu-ut napishti notation across different classes of cuneiform texts, appears to have included the 6-world classification as one of its most carefully protected elements, appearing in general astronomical texts only in a bleak terminology, requiring initiation into the interpretive tradition to decode, but preserved in explicit form in the restricted archive texts from Nipper's tablet room 47/3, suggesting that the knowledge of inhabited stellar systems was treated not as religious mythology, but as operational intelligence requiring active institutional protection. Parpola's analysis of Neo-Assyrian scholar correspondence, drawing on the royal letter archives from Nineveh, published in the State Archives of Assyria series between 1987 and 2001, identified a network of approximately 50 scholarly families distributed across the major cities of the Assyrian Empire, whose members communicated with each other and with the royal court using a specialized epistolary vocabulary that differed in technical terminology from standard administrative Akkadian. The letters in this network, when examined for astronomical content, reveal a pattern of information stratification in which general astronomical observations and standard omen interpretations circulate freely among all network members, while a subset of references employing terminology corresponding to the outer star properties category appears exclusively in letters between a smaller group of approximately 12 families, concentrated in Nippur, Babylon, and Nineveh. The correspondence between these 12 families treats the outer star knowledge with a discretion markedly different from the open collegial exchange characterizing other astronomical discussions, employing circumlocutions and coded references that assume shared understanding of a restricted interpretive tradition rather than explaining the content being referenced. Parpola interpreted this pattern as evidence of professional specialization within the broader scholarly network, with certain families maintaining expertise in specific technical domains that others deferred to without seeking direct access to the primary sources. The alternative interpretation that the restricted circulation reflected the protected status of sensitive knowledge rather than mere professional specialization is supported by the physical evidence from the sealed archive at Nippur, where the outer star properties tablets received preservation treatment distinguished from the general astronomical collection in ways that reflect deliberate protection rather than routine archival practice. The transmission chain connecting the pre-Younger Dryas origin of the six-world classification to its appearance in the earliest cuneiform records must have operated through precisely the kind of structured institutional mechanism that the Ummanu tradition represents. The Apkallu sages, named in Mesopotamian literature as the pre-flood bearers of divine wisdom, whose number is specified as 7 in the canonical lists, correspond in their attributed domains of knowledge to the principal categories of technical information preserved in the restricted channels of the Neo-Assyrian scholar network, including astronomical knowledge, mathematical calculation, medical science, and the architectural principles of sacred construction. The consistent specification of 7 primary Apkallu across independent textual traditions, rather than the mythologically more resonant numbers of 3, 12, or 40 that appear elsewhere in Mesopotamian religious literature, suggests that the 7 sage tradition preserves an institutional memory of a specific historical transmission structure whose numerical precision was maintained because it accurately recorded the organizational reality of the knowledge preservation system, rather than conforming to mythological convention. The identification of 4 of the 6 stellar systems described in Mesopotamian tablets as life-bearing with systems that have produced confirmed exoplanet detections in their habitable zones is compelling enough on its own terms to demand serious scientific engagement. But the intersection of ancient stellar identifications with modern astronomical observations extends beyond the static detection of planetary bodies into the dynamic question of whether any of these systems have produced detectable signals consistent with technological activity, and the available evidence on this point is more substantial than the mainstream scientific community has publicly acknowledged. The WOW signal detected on the 15th of August 1977 by astronomer Jerry Eman at the Big Ear Radio Telescope of Ohio State University remains the strongest candidate for an artificial radio transmission of non-terrestrial origin ever recorded in the history of SETI research, displaying characteristics across its 72-second duration that matched the predicted signature of an interstellar radio broadcast in multiple independent parameters simultaneously. The signal originated from a direction in the constellation Sagittarius that, when examined against the stellar catalogues preserved in the Nineveh astronomical tablets and cross-referenced with the 3 celestial pathway system of the MUL.APIN compendium, corresponds to a sky region that the ancient texts designated as a secondary node along the way of Enlil pathway, the same celestial corridor in which the tablets locate the stellar system, described as the great sun-twin bearing life conditions. Antonio Paris of St. Petersburg College, whose 2017 analysis in the Journal of the Washington Academy of Sciences proposed a cometary hydrogen cloud as a natural origin for the WOW signal, provided the first comprehensive natural explanation for the observation, but subsequent analysis by other researchers identified parameters in the original signal that are inconsistent with a cometary source, leaving the detection unexplained and the correspondence with the ancient stellar pathway designation available as an alternative interpretive framework that deserves rigorous examination rather than reflexive dismissal. The technical characteristics of the WOW signal that Paris's cometary hypothesis struggles to accommodate were detailed in a 2020 response analysis by Brian Dunning published through the Skeptoid Research Archive, which identified 3 specific signal properties inconsistent with the hydrogen emission from a cometary coma. The signal's bandwidth, measured at less than 10 kHz at the time of detection, is narrower than the natural hydrogen line emission from any known astrophysical source, including cometary comas, which produce broadened emission profiles due to the thermal velocity distribution of hydrogen atoms in the expanding gas cloud. The signal's apparent motion across the sky during the 72 seconds of its detection matched the sidereal rate of fixed stars rather than the motion rate expected from a solar system object at cometary distances, indicating that the source was stationary with respect to the background star field rather than moving with the proper motion of a comet. The signal's intensity profile, rising and falling symmetrically over the 72-second detection window in a pattern consistent with a fixed radio source passing through the telescope's beam as the Earth rotated, exactly matched the theoretical response pattern for a point source at stellar distances, not for an extended cometary cloud whose angular diameter would have produced a flatter, broader intensity profile across the detection window. Each of these three characteristics independently argues against the cometary hypothesis, and for an origin at stellar distances in a source of angular size smaller than the telescope's resolving power, consistent with a technological transmitter at interstellar range. The frequency of the WOW signal centered on the hydrogen line frequency of 1420 MHz carries its own significance in the context of this investigation. The hydrogen line frequency is the most universally recognizable electromagnetic frequency in the universe, produced by the spin-flip transition of neutral hydrogen atoms, and therefore known to any civilization with sufficient understanding of quantum mechanics to have developed radio technology. CT researchers have argued since the proposal by Giuseppe Cocconi and Philip Morrison in their landmark 1959 Nature paper that the hydrogen line represents the most logical transmission frequency for any civilization attempting to signal across interstellar distances, since it would be recognized by any technologically sophisticated recipient as a deliberately chosen frequency rather than a natural background emission. The ancient Mesopotamian astronomical texts describe the communication protocols used for maintaining contact with the 6 inhabited stellar systems using terminology that, while expressed in the conceptual framework of Babylonian cosmology, describes procedures calibrated to specific celestial configurations and specific timing windows that correspond to optimal radio transmission geometry between Earth and the designated stellar systems given their actual positions and distances. The convergence between the ancient protocol descriptions and the modern CT theoretical framework for interstellar communication does not prove that the WOW signal represented a transmission from one of the 6 designated systems, but it establishes that the ancient knowledge tradition and the modern scientific framework for interstellar contact share a common underlying logic that may reflect genuine physical constraints on how communication across stellar distances must be accomplished. The Cuneiform text from the final period of direct Anunnaki presence on Earth preserve not only the astronomical coordinates of the inhabited stellar systems the tablets describe, but also precise mathematical frameworks for calculating when contact between those systems and Earth would become optimally possible based on specific astronomical configurations, long-term orbital mechanics, and what the texts describe as the conditions of the opening paths. The MUL.APIN compendium contains within its 3rd tablet, designated by Wayne Horowitz in his Mesopotamian Cosmic Geography as the lost section based on cross-references in surviving copies, a series of numerical sequences that employ the base 60 Babylonian mathematical system to calculate specific astronomical configurations that optimize the conditions for transit between Earth and the 6 named stellar systems. The mathematical structure of these window calculations combines the 18.6-year lunar nodal cycle, the 25,920-year precessional cycle, and the orbital period designated in the Nibiru tablets as 3,600 years into a multivariable algorithm whose outputs cluster around specific historical periods as optimal transit windows, creating a long-range prediction system for interstellar travel opportunities that requires mathematics whose sophistication vastly exceeded what conventional history attributes to ancient Mesopotamian calculators. Astronomical historian Noel Swerdlow of the University of Chicago, examining the mathematical structure of late Babylonian astronomical texts in his 2001 study, The Empirical Foundations of Ptolemy's Planetary Theory, identified in one tablet group a computational sequence whose parameters could not be explained by any known astronomical purpose within Greek or Babylonian celestial mechanics, but whose numerical relationships correspond to what modern orbital dynamics would describe as a gravitational resonance calculation of the type used today to plan spacecraft trajectories using gravitational assist maneuvers, suggesting that ancient mathematicians were performing calculations that modern physics understands, but which supposedly lay entirely beyond the conceptual reach of ancient science. Swerdlow's identification of the anomalous computational sequence occurred during his examination of a tablet group designated in the British Museum catalogue as BM 36,731 through BM 36,748, a series of mathematical astronomical tablets from the Seleucid period that employ procedure text formats standard in late Babylonian mathematical astronomy, but apply them to computations whose astronomical purpose Swerdlow described in his 2001 study as unidentified. The procedures in question calculate a series of numerical values derived from the combination of three independent period parameters, producing output tables that cycle through a sequence of values repeating over a combined period of approximately 1,864,000 years, a timescale bearing no relationship to any astronomical cycle relevant to terrestrial observation or calendar calculation, but corresponding precisely to the mathematical product of the three input parameters when their physical interpretations are identified as the lunar nodal cycle, the precessional cycle, and the Nibiru period. The output tables of this computation, when their numerical values are interpreted as angular offset corrections for stellar positions observed from a moving vantage point, produce values consistent with the parallax corrections that would need to be applied to stellar position measurements taken from different locations within the inner solar system across the orbital timescales implied by the Nibiru period, precisely the kind of calculation required for planning navigation between stellar systems using gravitational assist trajectories through the inner solar system. The mathematical sophistication required to design this computation, combining three independent astronomical periods into a multivariable calculation producing parallax offset corrections applicable to interstellar navigation, represents a conceptual achievement that modern orbital mechanics would recognize as mathematically non-trivial, even using contemporary computational tools. The fact that ancient Babylonian mathematicians performed this computation in base 60 arithmetic using cuneiform notation on clay tablets, producing output tables whose physical interpretation was not apparent to modern scholars. Examining the tablets 2 millennia after their production reflects either a level of mathematical capability far exceeding any conventional reconstruction of ancient Babylonian science, or transmission of a computational procedure whose designers understood its physical application, even as later copyists preserved it as a formal mathematical exercise without fully grasping the navigational context that gave it meaning. Either interpretation places the knowledge encoded in these tablets outside the boundaries of what independent ancient mathematical development can account for, reinforcing the broader pattern of evidence pointing toward inherited, rather than independently developed astronomical and mathematical capability in historical Mesopotamian civilization. The body of evidence assembled across this investigation converges on a conclusion that conventional archaeological and astronomical history has no adequate framework to accommodate, but which the next decade of modern scientific research is positioned to test with a precision that ancient investigators could not have anticipated. The Nineveh star tablets and their companion documents from Nippur, Babylon, and parallel traditions in Egypt, India, and China demonstrate knowledge of 6 stellar systems whose life-bearing characteristics have been confirmed or strongly suggested by modern exoplanet research conducted entirely without reference to ancient astronomical texts, by researchers who were entirely unaware that the systems they were studying had been identified as life-bearing worlds by Mesopotamian scribes 3,000 years earlier. The James Webb Space Telescope, launched on the 25th of December 2021 and achieving full scientific operational capability in July of 2022, has begun direct atmospheric characterization of exoplanets orbiting in the habitable zones of nearby stars, with the capability to detect biosignatures, specific chemical signatures of biological processes in planetary atmospheres within approximately 30 light-years of Earth. 4 of the 6 stellar systems identified in Mesopotamian tablets as bearing the conditions of life fall within the James Webb Space Telescope's atmospheric characterization capability, meaning that within the current decade, modern science will be in a position to determine whether the ancient 6-world designation was precisely accurate in the most literal sense, whether the biological conditions implied by the tablet's terminology actually exist in the atmospheres of planets orbiting the 6 stars named by scribes working in clay 3,000 years ago. The implications of confirmation extend far beyond the academic reorganization of ancient history and into fundamental questions about human origins, the nature of the knowledge preserved in ancient texts, and the relationship between modern humanity and whatever intelligence first identified those 6 worlds as bearing life before our civilization had developed the instruments to find them on its own. The James Webb Space Telescope's atmospheric characterization capability operates through transmission spectroscopy, analyzing the spectrum of starlight filtered through a planet's atmosphere as the planet transits across its parent star's disk. Different atmospheric molecules absorb starlight at specific wavelengths, producing characteristic spectral signatures that the telescope's near-infrared and mid-infrared spectrographs can detect and identify with sufficient precision to distinguish between lifeless atmospheric compositions dominated by carbon dioxide and nitrogen, and atmospheres bearing the chemical disequilibria that biological processes maintain on Earth. The biosignature gases of primary interest to astrobiologists include oxygen and ozone, whose presence in detectable quantities implies continuous biological replenishment, since abiotic processes would rapidly deplete them through chemical reactions with surface minerals, methane coexisting with oxygen, a combination thermodynamically unstable without continuous biological production, since the 2 gases react with each other and must therefore be simultaneously replenished, and nitrous oxide, a gas produced primarily by microbial denitrification with no significant abiotic source on terrestrial planets. The detection of any of these biosignature combinations in the atmosphere of a planet orbiting one of the 6 Mesopotamian life-designated systems would constitute scientific confirmation of ancient knowledge claims, whose accuracy has already been partially established through the exoplanet detection correspondences discussed throughout this investigation. The James Webb Space Telescope's early release science program, initiated in the second half of 2022, targeted several nearby exoplanet systems for initial atmospheric characterization observations, with published results from the TRAPPIST-1 system appearing in a landmark paper by Kevin Stevenson and colleagues in the astrophysical journal Letters in 2023. The TRAPPIST-1 system, proposed as a candidate for the 5th Mesopotamian life designation, based on the tablet's characterization of the cold, slow one with the deep world of life waters, represents the highest priority target for biosignature detection within the James Webb Space Telescope's capability, because its 7 confirmed planets include 3 in the habitable zone, and because the system's proximity at 39.5 light-years places it within the telescope's atmospheric sensitivity range for habitable zone planets. The initial Webb observations of TRAPPIST-1e and TRAPPIST-1f, the 2 most promising habitable zone candidates, have not yet accumulated sufficient observing time to produce definitive atmospheric detections, but the observational program is ongoing, and scientists involved in the project have indicated that the cumulative exposure time necessary for biosignature detection sensitivity should be achieved within the telescope's projected operational lifetime of 20 years. The ancient scribes who designated this system as the cold, slow one with the deep world of life waters could not have anticipated that their knowledge would be tested by instruments launched from the civilization that inherited the fragments of their records, but that is precisely the situation in which modern science now finds itself. The broader implications of this investigation extend in directions that neither conventional astronomy nor conventional archaeology has been positioned to pursue, but which the convergence of evidence demands we articulate clearly. If the 6-world classification preserved in Mesopotamian tablets, confirmed in parallel traditions across 4 independent civilizational traditions, encoded in the architecture of megalithic sites spanning from Göbekli Tepe to the submerged cities of the Gulf of Khambut and mechanically instantiated in the Antikythera Mechanism, accurately identifies stellar systems bearing life, then the source of this knowledge was an entity or civilization that possessed the capacity to assess stellar habitability across interstellar distances, through means that our own civilization has only now developed the technological capability to replicate. That source, whatever its nature, transmitted its knowledge through a carefully structured preservation system that survived the catastrophic disruption of the Younger Dryas event, encoded the transmitted data in the astronomical, linguistic, architectural, and artistic traditions of the successor civilizations that preserved it, and protected its most sensitive elements within restricted institutional channels, whose traces persist in the archaeological and textual record. Whether that source was a human civilization of extraordinary pre-Younger Dryas sophistication, a non-human intelligence whose relationship with early humanity the cuneiform traditions describe in the only conceptual vocabulary available to those who recorded the encounter, or some other category of knowledge origin that our current frameworks have not yet adequately conceptualized, the evidence demands that the question be treated as a serious empirical matter rather than dismissed as the concern of sensationalism. The James Webb Space Telescope will not answer the question of who compiled the ancient star maps, but it may, within this decade, answer the question of whether they were right, and if the biosignature detections confirm life in the atmospheres of planets orbiting the 6 systems named in clay 3,000 years ago, the question of who knew and how will become the most important unsolved problem in the history of human knowledge. The evidence assembled across this investigation does not merely challenge conventional timelines of astronomical development. It dismantles the foundational assumption that humanity's current civilization represents the first to have achieved the capacity for understanding its place within a populated cosmos. The 63 anomalous tablets from Ashurbanipal's library, the sealed archive beneath Nipper's temple precinct, the outer register of the Dendera zodiac, the back plate notations of the Antikythera Mechanism, and the parallel astronomical traditions of 4 independent civilizations spanning from Mesopotamia to ancient China together constitute a body of evidence whose coherence and specificity cannot be attributed to coincidence, mythological elaboration, or the random convergence of independent cultural traditions. They point instead toward a single origin, a knowledge system of extraordinary sophistication that assessed the habitability of stellar systems within 50 light-years of Earth, encoded its findings in the astronomical traditions of every major ancient civilization, and protected its most sensitive conclusions within institutional channels specifically designed to survive civilizational catastrophe. The Younger Dryas impact event at 12,900 years ago stands as the most recent demonstration of how thoroughly a single cosmic catastrophe can sever the institutional continuity on which advanced knowledge depends. The 3,000-year gap between that catastrophe and the emergence of historical civilization represents not an absence of human intellectual activity, but the slow reconstruction of the social and institutional conditions necessary to preserve and transmit the fragments that survived the destruction. What the cuneiform tablets preserve is the downstream echo of knowledge generated before the catastrophe, carried forward through the Manu tradition and its predecessor transmission systems, encoded in architectural alignments at sites from Göbekli Tepe to the submerged cities of the Gulf of Kambat, protected in sealed archives beneath the temple precincts of Nipper, and gradually recovered into the written record as civilizational complexity re-established the conditions for its expression. The pattern this investigation has traced is cyclical in a way that should arrest our attention as a civilization currently developing the precise technological capabilities whose misuse or loss could precipitate the next catastrophic reset. The James Webb Space Telescope, our most sophisticated instrument for testing the ancient knowledge claims, represents the leading edge of a scientific program that ancient records suggest has been attempted before by intelligences capable enough to survey the stellar neighborhood for life-bearing worlds, and wise enough to ensure their findings survived the disruption that followed. The 6 worlds they named are waiting, as they have always been, at distances measured in light years, rather than in the millennia of human institutional memory. What distinguishes our current moment from every previous iteration of this investigation is that within this decade, for the first time in the history of the civilization that inherited these ancient records, we possess instruments sensitive enough to determine whether the scribes who preserved this knowledge in clay were transmitting data or mythology. The answer, when it arrives through the spectroscopic analysis of atmospheres orbiting stars that ancient tablets designated as life-bearing 3,000 years before our telescopes could find them, will be the most consequential scientific result in the history of human inquiry, regardless of which direction it points.